coming soon, or it could be up now, I'm going to be selling our whole controller, the whole game I've made. It's about 6 to 8 months of work for you to be able to download and get yourself. Like I said, that's linked below. You'll be able to use this as a template for your own games. In making a game, it's always good to have a plan. So here's the plan. We're going to make a 2D platformer, and this guy is going to be our main character. Plan to use this Tilemap by Kenny that I'll link in the description, and draw any other assets we might want. In our platformer, our goal will be to collect enough points to get to the next level. So we'll track our points collection by filling up this gauge. And to fill up this gauge, our player can collect stars. By picking these up, we'll slowly fill up our star gauge. And once full, we'll go to the next level. On our levels, we'll also have enemies. Our enemies can hit us, so we'll need a health bar and a way for our player to attack our enemies. Then when enemies are killed, they'll drop more collectibles to fill our gauge. That's the basic idea, but we can add more features like wall jumps, wall slides, dashing, traps, puzzles, but we'll see where we go. This list is my current tutorial plan, but again, we'll see where we go. So let's get started. To make this game, we're going to be using Unity, so download it if you don't have it already. Then once you have Unity Hub opened, select a new project, and we're going to go 2D, since this is a 2D game, and name our project. Then click Create Project. Now our Unity project is opened. This is the default layout Unity opens in, but I like to move my windows around a bit just so you can see everything at once. So I'm going to move mine around. You can not do this if you don't want to, but if you want yours to look like mine during this course, you can. Having your layout like this means you can see everything at once. If you want to save this layout for future, you can go to Window, Layouts, and then Save Layout. Then if you ever open Unity and want this back, you can just go to the Window, Layouts, and then click that again. First of all, on the left in our hierarchy, we want to right click and go 2D Object, Sprites, Square, and this is going to be our player, so you can name this player. For our player to move around, we're going to need to add some components. So in the inspector, click Add Component, and first we'll add a rigid body 2D. This gives our player physics, gravity, and mass. Under constraints, I'm going to freeze our Z rotation so our player doesn't spin around when it hits things. Next, I'll add another component, which will be a box collider 2D. If we zoom in on our player, you can see we have this green box around him, which is our collider. This will tell us when our player is touching things and allows it to collide with other objects, like our platforms or enemies. Right-click, 2D Objects, Sprite, Square. Drag this down and out. We'll name this platform. And add a box collider 2D. For this tutorial, we're going to be using Unity's input system. So we're going to need to install that using Unity's package manager. So go to Window, Package Manager. Then in this drop down, change it from in project to Unity registry and search for input system. Then select input system and click install. Once this is installed, we do need to restart our editor. So once we've restarted, close our package manager, select your player, click Add Component, and search Player Input. We'll add our player input to our player. We have no actions yet, so click Create Actions. We'll call this Player Controls. Now you can see by default we've got some actions set up for us. So we've got our movement, which is all we need for now. We'll add our jump later once we get to it. Now all we want to do is under Behavior, select Invoke Unity Events, since we want to set up our own events in script. You can see this creates this events drop down. So you can drop this down and open up player. You can see we have our move event here. This is what we'll call in our script. So let's add a script. Click Add Component, New Script, and call this Player Movement. Then double click on this to open it up. In our script, we'll want some variables. We want a public rigid body 2D called RB, a public float called move speed, which we'll set to a default of 5F, and a float for our horizontal movement. At the top, to use our new input system, we'll need to add using Unity engine dot input system. So now we can write our input actions. So we'll type public void move, and we'll pass in our input action dot callback context. We'll call this context. Then we'll set our horizontal movement to be equal to our context dot read value vector 2, and we'll grab the x. So that's the movement on the x-axis, so our horizontal movement. Now we'll get our player to move. So I'll set our rigid body's velocity to equal a new vector 2, and we'll pass in our horizontal movement times our move speed and our rigid body's current velocity dot y, so we keep our downward momentum. And that's it for the script. So back in Unity, we'll make sure we drag our rigid body 2D into our player movement script, then open up our player input. Under Events and Player, we'll add a new event for move. You can drag your player object from your hierarchy into this move event. Then under no function, we'll go down to player movement. And you can see move is at the top here because we have an input action callback context passed into our parameter. So if you select move and then press play, our character moves with our arrow keys. And that's it. We can also up our movement speed since we made this a public variable. You can see it down in our movement script. In the next episode, we'll be looking at tile maps and getting our platform set up and looking cool. In a previous video, we got our player moving. Now we're going to set up our tile maps, design our first level, and add our tile map colliders. So first of all, I'm going to delete our existing platform. Then I'm going to select our main camera and set the background to be black. Then I'm going to grab our tile map asset by Kenny, which I'll link below. And make sure you grab this transparent one, otherwise our collider will be boxy. Select our sprite and set the sprite mode to be multiple. Set the pixels per unit to be one less than they actually are, so ours are 16 by 16. By doing this, you fix tearing, the lazy man's way. And set filter mode to be point no filter and compression to be none. And click apply. Click sprite editor, slice, grid by cell size, and set this to be 16 by 16 and click slice. Then click apply. Close this, go to window, 2D, tile palette, and drag this in with our inspector. Select create new palette. I'll just call this palette. I'm going to create a new folder for this called Tilemap and click select folder. Then click on our sprite and drag it into our palette we've just created. Select our Tilemap folder, and our sprites get converted into this nice palette that we can select and paint on our scene with. But before we can paint on our scene, over in the hierarchy, right click and go 2D object, Tilemap, rectangular, and I'll call this platforms. Now you can see our tiles appearing on our scene. So we can go to our palette, select the tiles we want, create a platform. If we press play now, our player will fall straight through this because we don't have any colliders anymore. So select platforms in the hierarchy and go to the inspector. I'm going to add a new component to search for Tilemap collider 2D and add this. And you can see a collider has been added around each one of our sprites. Because this is transparent, it tries to kind of draw around our sprite shape. By having around each sprite, it's not very, can't think of the word, but good for performance. So we're going to add another component and search for a composite collider 2D. Then all we have to do in our Tilemap collider 2D is tick used by composite. You can see this changes into one great big line. Instead of separate sprites, it draws around our whole platform. It's also added a rigid body 2D, so just make sure you set it from dynamic to static so our platform doesn't fall. Now when we press play, our player can stand up. So now we can design our first level, which I've just done here. You can see I've added all these platforms and a base floor. In the future, we're also going to implement some wall jumps and wall slides. So to do that, we'll add some walls. I'm going to create a new tile map in my grid for my walls, which will keep things easier in future implementations when we need to differentiate between our grounds and our walls. So right click on grid, go 2D object, tile map rectangular, and we'll call this wall. Then click on the tile palette. And under active tile map, make sure you select wall. And then I'm going to select this little tile here, which matches our ground. Just drag it all the way up and then do the same on the other side with the opposite sprite. Now back in the inspector with wall selected, we're going to add a Tilemap collider 2D and a composite collider 2D. Same as last time. We'll select use by composite, open up our rigid body 2D and select static. If we press play, our character can move around on our ground. Now you can see in our scene he does walk off to the wall and bumps his head, but in our game view our player has now walked off the side of our camera. So really quickly, let's get our camera following our player. Go to Window, Package Manager, and search for Cinemachine. Select Cinemachine and click Install, and close this. Right click in our hierarchy and you'll see Cinemachine down the bottom. You can go to 2D camera, and then in this you can see we have a follow slot in the inspector. If you drag our player into this follow spot and press play, our camera now follows our player. We're finished. Level 1 is designed. One down, as many as you want to go. In our next video, we're going to implement jumping, double jumps, and add some feeling to our jumps with gravity and friction. Very exciting! In this video, we're going to get our character jumping around onto these platforms with double jumps and gravity effects. So let's go! First things first, let's add a jump input into our player controller's input system. So let's open up player controller by double clicking on it. And in here, let's tidy it up a bit. We don't need this look and we don't need this fire for now. So our move currently uses our up arrow and down arrow, which we're not using. We only use left and right. So we can remove these as well as W and S. Now we can add a new action for jump. So click the plus at the top and name this jump. Click on the no binding, click on the drop down by path and click listen. I'm going to press up arrow And I'm also going to add another one, which I'll click listen and then press spacebar. So we can jump using our up arrow on our keyboard or spacebar. You can also add W if you like, which I'll do too, since we can move left and right with A and D. Then we click Save Asset and close this off. Now back on our player, if we go under Events, then Player, we can see our move function. Then we have a new one for jump. So let's double click on our script to open it up and add a function for our jump. To keep your scripts tidy, you can add headers to your scripts, which display it back on your objects, so it's easy to keep track of all these public parameters. So I'm going to add one for movement and one for jumping. For jumping, we're going to want to add a public float called jump power. And I'll set this to a default of 10f. Now we need to make a new function, same as our move, passing in our input action callback context. So inside here, we're going to say if our context was performed, which means our button was fully pressed down, then our rigid body's velocity will equal a new vector 2. We'll keep our horizontal velocity, pass in the x, and our y is going to be our jump power. So back in Unity, under player input and under events, player, let's add in our new function, drag in our player, under player movement, select jump at the top. When we press play, then press space, or up on the arrow key, or W, our player jumps. To make our jumping a little more interesting, back in the script, we can type else if context.cancelled, which means we pressed our button but didn't hold it down, so like a light tap. Then we can set our rigid body velocity equal a new vector 2, pass in our rigid body velocity x, and instead of jump power, we'll set it to our rigid body's current velocity dot y times 0.5. So basically, if we hold down our jump button, it'll be the full height of our jump power. Else if we do a light tap at the jump button, it'll be half the height, or just a small little hop. So if I do a light tap, it's small, and if I hold down, it's big. Now currently, if I keep pressing jump, our character can fly. So what we need to do is check when our player is on the ground, and only allow him to jump when touching the ground. So back in our script, let's add a new header called ground check. And under here, we'll want 3 new variables. The first one being a public transform for our ground check position or ground check pos. Next will be a public vector 2, which we'll call ground check size. And just to help us out, I'll set this to a default of some basic values. So 0.5 and 0.05. And last of all, we want a public layer mask called ground layer. We'll use this to check if we're touching anything that's tagged with ground. To be able to visualize our ground check size, what we can do is add a new function called onDrawGizmoSelected. We can set our gizmo's color to be white, and then we'll tell Unity to draw us a cube where our ground check is. So we'll pass in our ground check position, dot position, and our ground check size. So we can see what this looks like if we go back into Unity and add a new empty child onto our player. Call this ground check. On our player, we can now drag in our ground check object into our ground check position. Now if we click on ground check, select the move tool, and then move this down, line up the line just kind of with the feet of our player. Select our player again, and if we zoom in, you can see we have a white box here. We can change the width and the height of this. We can get this to match our player's feet. However, we want our ground check to match our sprite that we pass in. So while we're here, if we open up our sprite renderer and open up our tiles that we added in, I'm going to search for our player sprite that we wanted to use. There he is. Cool. So if you drag that into the sprite box, you can see we have our player. We want to open our Box Collider 2D and actually make sure this fits around our player nicely as well. And I've just noticed our ground check, it wasn't filled in. So if we say draw wire cube, we can see now a nice white line around our player's feet. I'm going to go back down to our player script and edit our ground check size to match our player's feet. The height you'll want just to be just below the feet, so I'll do 0.4. So as soon as it touches this box, we're going to say we're on the ground and you can jump again. While we're setting up parameters, let's set up our ground layers layer mask. So you can see in here we've got all our different layers. If we click on our ground grid, in our layers we'll want to select ground in here. If you don't have ground in here, you can click add layer and just add it to one of these user layer boxes. So back to player, ground layer is ground. Now whenever our ground check position, so our ground check object, touches anything tagged with that ground layer tag, we'll know we're on the floor. So back in our script, we can write a new function. which returns a ball, the chord is grounded. By default, we'll get this to return false. Then we want to say if our physics 2D dot overlap box, then we'll want to pass in the point. So that'll be our ground check position, dot position, the size, which is our ground check size. Our angle is 0, so that's fine. And our layer mask, which is our ground layer. So if our ground check box is overlapping our ground layer, we'll return true. So before we jump, we want to check, are we grounded? So if is grounded, do our jump logic. I'm spamming space. Let me see if you can hear. Yep, he's only jumping when we touch the ground. Cool. Aha, another problem. Do you see I'm sticking to the side of this platform? Our player has friction, so it can grab onto things. I got a fix for this. In our player's rigid body 2D, we can set our player's material. In your asset, right click, go create 2D, physics material 2D, and I'll call this frictionless. Then set our friction to be 0. Select our player and drag frictionless into our material. Cool. We can no longer stick to that platform. But you know what? I can't actually reach that platform. It'll be handy if we had a double jump. You knew I was going to do a double jump. Okay, back in our script, let's add the functionality for a double jump. So up the top, let's add 2 new variables. One for our max jumps, which we'll set as a default to 2. This can be a public int. And then another int, which can be private, as our jumps remaining. Now we don't want to be able to jump only when we're touching the ground. We want to be able to jump mid-air. So what we want to say is, if our jumps remaining is greater than 0, we can jump. And after jumping, we want to make our jumps remaining go down 1. So you can do jumps minus minus. We want this down in our light tap as well. And now, when we touch the ground, instead of just returning true, we can set our jumps remaining back to our max jumps. Don't need to return false, and we can make this void instead of returning a ball. I'm going to change this name to be ground check instead of is ground. And since we're not calling this before we jump each time, we're going to instead call this in our update function. So we're constantly checking if we can jump and how many jumps we have remaining. Cool, now we can reach. Now let's play around with some gravity. This will help your platformer feel more unique, and you'll be able to personalize it to the feel you want. But basically this is going to affect the way we fall. So back in our script, let's add one more header, call it gravity. And here let's get a public float called base gravity. I'm going to set mine to a default 2. And another public float, and we'll call this max fall speed. I'm going to set mine to be 18. And then another public float, and this will be our fall speed multiplier, and set to a default of 2. We'll keep all of these public so we can play around with them to find the right feel while testing our game. So let's create a new function for handling our gravity. We'll say if our rigid body's velocity dot y is less than 0, then we're going to set our rigid body's gravity scale to equal our base gravity times our fall speed multiplier. What this does is makes your player fall increasingly faster, so it doesn't feel as floaty. In case you have a big fall and you don't want to smash through the floor, we'll cap off our player's fall speed by going RB velocity equals a new vector 2. We'll pass in our normal x velocity. And we're going to use a math function. So type mathf.max and pass in rb.velocity.y and then minus our max fall speed. This will cap our player out at their max fall speed so they won't fall any faster than whatever we pass in, mine being 18. Now, if we're not falling, we'll say else our rb.gravity scale goes back to our base gravity. And we'll call our gravity function up in our update. Back in Unity, make sure you got play focused on so we'll be able to edit these gravity parameters as we play. You can see now our player falls a bit heavier, but still gets to jump nice and light. Try and get him to fall from really high so you can see. Cool. So now you can play around. If you want more of a floaty game, you can set your max fall speed to something lower, like 5. You'll see we fall down real slow. You can still control your character while in the air. Maybe for like a parachuting game or something. Or you can set it really high. 40 might be a bit much. He drops really fast. I quite like 18. Gives a weighted feeling without feeling too fast. But if you wanted to make a platformer where you had to move side to side while falling and avoid obstacles or something, you might want to set this to around 10. Gives you a little more time to react. Maybe even lower. But that's it. That was quite a complicated one, so good job. In the next video, we're going to take a look at wall jumps. Because right now we just slide off the side. By the end of this video, we'll have our character wall sliding, which will slow down our player's full velocity, and wall jumping, which will let our player jump off walls and bound in the other direction. I've added in this wall to test our player's wall jumping on our wall grid and this platform to try and reach. We'll start with wall slides. So for jumping, we added this ground check to our player, which we can see and edit using a gizmo, which is this white box below our player. For wall slides, we'll add a wall check. So right click on our player and go create empty and name this wall check, and the rest we'll do inside our script. So open our player movement script, and we'll want exactly the same as our ground check. So we can copy that and paste it, but we'll rename the header wall check, and all our variables will replace ground with wall. Then down where we draw a box for our ground check, we can do the same for our wall check. So copy and paste these. We'll make this one blue and get our wall check position and our wall check size. Back in Unity, we can now click on our player and drag in our wall check to our wall check slot. You can see this is positioned at the top of our player's head. On your wall checks transform, drag this over to the edge of your player's collision box. Click on your player and check this fits. If not, you can move your wall check size X and Y till it fits nicely just on the edge of your collision, which is our green box. So when this blue box hits a wall, we'll start wall sliding. And make sure you position your wall check the way your player is facing. Because of this, we're going to want to flip our character when we change direction. So back in our script, we'll add a new function called flip. Here we'll say if we're facing right, which is a boolean we'll add at the top, and our horizontal movement is less than 0, which means we're moving in the left direction, then we'll want to flip so we're facing left. Or if we're not facing right and our horizontal movement is greater than 0, then we'll want to flip. Then we'll set is facing right to equal whatever it's not currently, so flip in the ball. Set a vector free for local scale, which is going to equal our current transform dot local scale. Then we'll set our local scale's x to times equal -1. By timesing this x by -1, we flip our sprite, so make whatever the x is negative. If we look in Unity and make our scale's x -1, you can see we face the other way. So we want to set our transform dot local scale to equal this new value. And that's it. So let's add in this is facing right variable, copy this, and at the top we'll go bool is facing right equals true, because by default our sprite is facing right. You can set this to false if your character is facing left by default. Now down in our update, we'll call flip. Just to tidy things up, I'm going to move this falling gravity process into its own function. So down below I'll add a private void process gravity. And copy this and call it below our ground check. So now when we move our character around, it'll change direction. Next, we'll add in our wall slide. So add a new header called wall movement, and then add a public float wall slide speed. And I'll set this to a default of 2. Then we'll also want a ball that is called is wall sliding. Cool. So now we have process gravity. Let's add process wall slide. Private void process wall slide. So let's think about how to wall slide. We need to be not touching the ground on a wall and be holding our movement towards the wall. So our movement can't be 0. So we're going to need a boolean to check if we're grounded or not. In our ground check, we currently set this with our double jumps. But to make this easier, let's add an is grounded boolean. And in here we'll be setting this to true. And for when we're not touching the ground, we'll set is grounded to be false. Let's go to the top, and under ground check, we can add our ball is grounded. Take this, down in our process wall slide, we can now go if we're not grounded, and that's it so far. So next we want to know if we're on a wall. So like our grounded check, let's add a wall check. So we'll go private void wall check, and here all we want to do is know if our wall check is true or false. So we can copy our physics 2D overlap box, same as the ground check, and type return, paste what you've got, and then replace ground check position with wall check position, ground check size with wall check size, and then ground layer with wall layer. Oh, and this can't be a private void. It has to be private bool because we're returning true or false. So now we can copy wall check, and down in our process wall slide we're building, we'll say if not grounded and wall check. So are we on a wall? And we want to check if our horizontal movement is not 0. If we weren't moving, we'd fall down to the ground and not slide. So now let's set up our wall slide. We'll set is wall sliding to true, which we're going to use for wall jumping later. Else is wall sliding equals false. And then in our true wall sliding section, we'll make our full speed slow down. by capping our fall rate. To do this, we'll go rb.velocity equals a new vector2. We'll keep our same rb.velocity.x. Then we're going to call a math function. It's going to be mathf.max. Then we pass in our current value, which is our rbvelocity.y. Then we'll type minus and pass in our wall slide speed. This caps our fall rate. Now let's copy process wall slide and up in our update, paste this in. Back in Unity, select our player and scroll down in our player movement script. We have wall layer set to nothing right now. So we're going to need to add wall to our layers and then make sure our wall grid object is assigned. So select our wall tilemap and in the inspector under the layer drop down, click add layer and then add wall to one of these user layers. Back on our player. Now we can go to wall layer and select wall. So this is before our wall slide. Now when we press play, if we run over to a wall, jump up and keep pushing our movement to the side, we'll slide down slower than before. And if I let go, we drop down fast. Cool, so now we have wall slides, let's add wall jumps. So when we jump off of a wall, it pushes us in the other direction. So back in our player movement script, we're going to want some more variables. I'm going to keep these under our wall movement header and add ball is wall jumping, float, wall jump direction, another float for wall jump time. And we'll set this to a default of 0.5f, and another float for our wall jump timer, and then a public vector2, which we'll call wall jump power. We're going to use this to determine how far we jump across on the x, which I'll set to a default of 5, and how high we jump on the y, which I'll set to a default of 10, as that matches our normal jump power. With power in our x, it'll make us bounce off of the wall instead of going straight up. So now down in our jump function, we'll add some code for our wall jump. So we'll say if context.performed and our wall jump timer is greater than 0, then is wall jumping, we set to true. And our rb.velocity is going to equal new vector2, and we'll pass in our wall jump direction times our wall jump power.x, then our wall jump power and our wall jump power.y. Doing this will make us jump away from the wall. Now we'll add a process for processing our wall jump. So down under our wall slide, we'll go private void process wall jump. And in here, we're going to check, are we wall sliding? Then we're no longer wall jumping. Our wall jump direction is going to be equals the minus of our transform.localScale.x, so that when we jump in the opposite direction to the way we're facing. And we'll reset our wall jump timer. So wall jump timer equals wall jump time. So then we'll say else if we're not wall sliding, but our wall jump timer is greater than 0, we'll get our wall jump timer to tick down by doing minus equals time.delta time. Now the final function we'll need is a private void cancel wall jump. So we can set our wall jump back to false. So is wall jumping equals false. The reason we want this in its own function instead of just setting this itself is because we're going to call this in an invoke. Using an invoke is handy when you want something to be finished when a timer finishes. So we'll take cancel wall jump and back up in our wall jump functionality in our jump function. Under our RB velocity, we're going to set our wall jump timer back to 0 and then call invoke, name of, and pass in our method. So cancel wall jump, then pass in our wall jump time, and after testing, it works a little better if you add 1 to this. So it's just 1 millisecond over our jumping time. Hopefully that makes sense, but basically our wall jump will last 0.5 seconds, and then we can jump again after 0.6 seconds. This keeps movement fluid. Now when we hit a wall and start wall sliding, we want this to be called instantly. So back down in process wall jump, we're going to say cancel invoke, name of, cancel wall jump. So as soon as we wall slide, we can jump again. Let's call process wall jump up in our update, so under process wall slide. And then we actually have one more bit to add to our jump function. So when we wall jump, we want to turn and face the other way because we've jumped off the wall. So we need to force a flip. We're going to say if our transform.localScale.x is not our wall jump direction. So if we're not facing the way in which we're jumping, we're going to scroll down and take what was in our flip and back up. Paste this to force a flip. Cool. Now to stop any movement, when we move our character using RB velocity equals a new vector2, I'm going to put this below all our processes and checks and say if we're not wall jumping, then we can move. And we also don't want our flip to change when we're wall jumping, so I'll place that in there as well. So now when we go to Unity and press play, I'll start wall sliding down our wall and then jump in the other direction. You can see how this bounces our player off the wall in the opposite direction that we're facing. I built this little wall jump So now you can jump side to side and get your player to the top of a high platform. If we play focused, you can try some stuff out with our public variables. Like the wall slide speed you could lower, so you go really slowly down the wall. Or maybe you touch a slippery wall and it makes you go down really fast. You can also play with these wall jump powers. So if I set this to 10, you can see we now spring off the wall really far. But I find halving your jump power for your X and keeping your Y the same as your regular jump power feels the most natural. And that's it. We finally got our player movement basically down. Oh, I can't get up. Nice. Now we're going to add animations to all of these movements. So let's get started. To do animations, we're going to need to add some windows. So if you go up to the top and click window, go down to animation, animation, and I'll drag this right down the bottom. Then go back up to window, go animation, animator, and we'll leave this tabbed here. Cool. Next we'll bring in the sprites we want to use for our animations. Some of these are single frame assets I've taken from Kenny's Tilemap, and others are ones I made myself by editing his sprites. You can get all these on my Patreon if you want to use them. So I'm just going to drag these into our sprites folder in our assets in Unity. Double click on here, then in this folder, you can hold down Control and select all our character sprites and avoid our Tilemap. Then for all of these, I'm going to set them all to 16 since they're 16 by 16. Filter mode to point no filter, and then compression to none, and click apply. Then I'm going to go to the ones that are multiple sprites and hold down Control, so that's idle and walk for me. Click on these and change sprite mode to be multiple. Click apply. Then individually, I'll go to idle first, go sprite editor, click slice and grid by cell size, then set this to be 16 by 16 and click slice, apply, close that one off, go to walk, sprite editor, slice, grid by cell size, 16 by 16, slice, apply. And now you can see if we open up our idle, you can see it split this into two separate sprites. We can use these as our frames in our animation. For jumping, wall slide and fall, I've just got single frames. Now, if we go to our player, click add component, search for animator and add an animator component. Then while selecting our player, down in our animation window, if you click create, and then I'm going to go back into our assets and create a new folder, and this will be for our animations. So if we go inside here, and I'll name this animation idle. You can see this automatically created a controller for our player's animation. If we go into the animations folder, you can see we've got a player controller now, as well as our idle animation. We'll come back to the controller later once we've made all our animations. If we go back to our sprites folder and open up idle, we can drag each of these frames into our idle animation down the bottom. The diamonds in here show your frames, and the numbers at the top is the time in which that frame will play. So if we zoom into our player and then press play, you can see he's going way too fast. So we can click and drag out our second frame to around 0.30. And if we press play again, you can see he's kind of jittering. That's because it gets to the second frame and then instantly snaps back to the first. To fix this, we can add another frame, either the first or second. Place it at about 1. You can see his speed's much better. Next, we'll add the walking animation. So under idle in the drop down, you click on this and click create new clip. Call this walk and move back from assets into the animations folder. In our new animation, we can open up walk and drag in our sprites. For our walking animation, we'll want to be a bit faster. So I'll leave it at these 0.5 intervals and add another frame in at 15 so we don't get that clipping. Cool. Next, we'll do our jump. So again, new animation. We'll call this jump. Then I just have one frame for my jump animation. So we just drag that in. Same with the next two. Wall slide, drag in our wall slide frame, and fall, drag in our falling frame. You may have noticed in our top animator controller, you can see all the animations we're creating. This is what we're going to set up next. So we don't need this animation window anymore. I'm going to close that tab and expand this down. I'm going to move these up for now. Now first, let's get our character walking. So this default entry going into idle is fine. We'll bring over our walk animation. So to get this animated, you right click on idle, click make transition, and you'll see we can have a transition going towards walking. Then we're going to want to be able to transition back from walking to idling. For these transitions, we can add conditions. So to go from idling to walking when something happens. To do this, so under your animator tab, go from layers to parameters and click the plus button. Then select float. For walking, we're going to use our magnitude. So select your transition that goes from idling to walking. So this bottom one. Click the plus under conditions and say if our magnitude is greater than 0, which is the default. Then in our transition from walking to idling, click the plus, and we want if our magnitude is less than 0.1. We're going to edit a few extra settings here. So back on the transition from idle to walk, we'll untick has exit time, open up the settings, untick fixed duration, and set transition duration to 0. All of these settings mean that our animations will be quick acting and snap to one another. We'll do the same for walking to idling. Untick has exit time, untick fixed duration, and set transition duration to 0. The next step would be to add the script and show this working, but so we don't have to click around all over the place, let's get the controller set up and then we'll go into the script. So next, let's add our jumping. We'll grab our jump animation, and we want to be able to jump from any state, since we could be idling, walking, or wall sliding. So right click on any state and go make transition and select jump. Then in parameters, click the plus and add a trigger, and we're going to call this jump. Now click your transition to jump. We want the same settings as before, so untick fixed duration, 0 transition duration, and then in conditions, click the plus, then change magnitude to jump. That's all we need. Now after jumping, we want to fall. So we'll grab our fall animation and place it under our jump. So right click on jump, make transition, and click on fall. Now on this transition, we do want to have an exit time, and our exit time is going to be 1, and we'll set our transition duration to 0. Then our interruption source is going to be next state. So how we know when to transition from jumping to falling will be when our player has reached their peak and begins to fall down. So that'll be when our y velocity is less than 0. So in parameters, let's add a float and call this y velocity, and click the plus in our conditions on our jump to fall transition and select y velocity less than and leave that at 0. Next, we'll want the same thing from idle to falling in case we walk off a platform instead of jumping off a platform. So on here, we actually don't want an exit time this time. We do want a fixed duration, and we're going to set this to 0. Our conditions again will be y velocity less than 0. Now to know when to transition from falling to idling, so make a transition from falling to idling. We'll set this transition duration to be 0.2, just a little bit less. Our interruption source of next state, so we can get walking instead of idling if need be. And our condition for this is going to be if our y velocity is greater than minus 0.01. And untick fixed duration. Cool, now we have one more animation to add, which is our wall slide. Like jumping, this can be done from any state. So do make transition from any state to wall slide and select this transition. For this, we want no exit time, no fixed duration, transition duration to 0. And for this condition, we're going to need another new parameter, and this is going to be a bool. We're going to call this is wall sliding. We'll say in our conditions, select is wall sliding is true. Then we'll want a transition from wall sliding to idle. Select this. Then we'll say, yes, we want an exit time, and then set transition duration to 0. And in our conditions, probably guessed it, is wall sliding is false. Now just a heads up, make sure your parameters are all spelt correctly with the right casing. Since when we set these in our script, it'll have to be exactly the same casing. I'll change jump to be a lowercase j, so these are all consistent. Cool, now let's go to our script. So double click on player movement, and at the top, we're going to want a public animator. Then down in our update, underneath where we flip, we're going to go animator.setFloat, and in here we pass in our ID. So there's going to be a string or an int, but we're going to use, like I said, our names. So first we'll set y velocity, then pass in the value. So that's our rb.velocity.y. Next we'll need one for magnitude. So animator.setFloat magnitude. And pass in rb.velocity.magnitude. In here we can also set our animator.setBall and set our is wall sliding. Since we already have a ball called is wall sliding. Cool, now the last one we'll need is down in our jump function. After we jump, we want to set our animator.setTrigger, and then we pass in jump. Oh, and we set that to a lowercase j. Yeah, and make sure your casing is right. If we highlight this and press Ctrl+C to copy, then down where anywhere we jump, we'll paste this in. So when we do a light tap, we jump. Then when we wall jump, we jump. So we'll paste this in here as well. And that should be it. Back in Unity, when we press play, if you're in focused mode, you can watch our controller switch between our different animations. So if I walk and jump and fall, you'll see it's moving. So here we can see our player walking. If I jump, you can see it does our little jump animation, which is like a pretty little ballerina leap. And as we fall, puts his little arms up. Now let's test our wall sliding. So if I just wall jump up a bit, oh, you can see he does that cool little Spider-Man grapple. There we go. We'll do some more of that today, where by the end of this video, we'll have particle effects for when our player jumps and changes direction, kind of like a smoky dust cloud. So let's go. So to add a particle effect to our player, we're going to right click on our player object in the hierarchy, go down to Effects, and then Particle System. You can see instantly these white blobs coming out from our player. Next, I'm going to set the material for our particle effect, and I'll select Sprites Default. Now we have white squares instead of those glowy blobs, which suits our pixel game. You can change this to be whatever material you like to go with your game. Next, I'm going to set the max particle size to be something smaller, like 0.2. Cool. I'm going to collapse the renderer. Next, I'm going to go to Shape. This is the shape in which your particles appear. So we want ours to be a box. I'm going to set the Y to be 0 and the X to be 0.5. So it comes from a smaller range. Cool, we can close off shape. Now I'm going to go up to the very top. I'll actually rename this while we're here. Call it something like Smoke FX. And so we can see our player, we can set the start size in the Smoke FX section to be 0.2. And then we'll move this down so it's down by his feet. I'm going to do this in the position at the top. So I'm going to set this to minus 0.5. So you can see it appears around his feet. We're going to look at the start lifetime. So what this does, as it says in the tooltip, is when the particle dies. So how long does it last in our scene? So I'm going to set this to something way smaller, like 0.5. Next, we want our simulation space to be world, and we don't want it to play on awake. You can see it's kind of stuck at his feet right now. It leaves a little trail, but we want it to go more like up and out as he goes. So it kind of fades away. This is like a little snake tail. So we'll go to velocity over lifetime. We tick this, then type minus 0.1, so you can see it kind of trails out behind, and then 0.1 on the Y, so it kind of goes along and then out. And we also want this to be world. To add some more particles, we can go to emission, and rate over time we can change from 10 to be 30. You can add more or less depending on the kind of feel you want. So now we have kind of a bunchy up snake tail rather than a straight line, since we're emitting more particles. Next, I'm going to add a color over lifetime, so take that on. Then if we click on this white box, click on the top right hand toggle, and I'm going to set the alpha to 0. So it's going to fade from white to transparent like this. And on the same kind of idea, I'm going to do size over lifetime. Tick this on. And in this size drop down, if you click on it, you get given these default options. I'm going to select the second to last one. So it goes from its full size down to nothing. So if we press play, you can see now we get a nice fade away of smoke. Cool, now back up the top, I'm going to set our duration to be 0.2. I'm going to turn off looping, and I'm going to turn off play on awake. So now when it plays, it'll just be like a little puff of smoke rather than our long tail that continues. I'm also going to change our start color to like a purpley pinky, just so it stands out in our scene. Cool, now because we turned off play on awake and turned off looping, this doesn't appear anymore. So we need to play it in our script. So open your player movement script by double clicking, and at the top we're going to want to add a public particle system, and I'll call this Smoke FX. I'm going to copy our Smoke FX variable, and then remember we said we want it whenever we jump and then whenever we change direction. So if we scroll down, we can basically use everywhere our animator sets the trigger to jump and be where we play our smoke effects. So we go smoke effects dot play. You can see now we're about to have some repeated code. We're going to have smoke effects play and animation set trigger jump playing 3 times over. You don't really want to repeat in your code, so what we can do is go down and write a new private void jump effects and then paste our code into here. Now instead of repeating these 2 lines, we can just call jump effects. So replace them all. Now it looks much tidier. Now we also wanted to play our smoke effects when we change direction. We do something else when we change direction in our code currently, and that's when we flip. So if we scroll down, we have our code for flipping. So in here, we want to say smoke effects dot play. Because we can move in the air and we'll flip while facing in the air, we want to do this only when we're on the ground. So we'll say if rb.velocity.y equals 0, meaning we're not falling down. We'll copy our smoke effects dot play and play it in here. Cool, and that's it. So back in Unity, select your player. If I collapse these and go down to our player movement script, we have a slot for our particle system for Smoke FX. We drag Smoke FX into this, then press play. Now when we jump, we get a nice little particle smoke cloud. So let's try changing direction. Cool, very nice. And double jumping. We can make it so it only happens on the first jump, but I kind of like the cute spacey effect of him having a trail whenever he jumps. And that's it. Particle systems can be highly customized, so I suggest messing around with them and finding what you like best. A fun and easy way to add your own particles is the text to sheet animation. If we turn this on and go to sprites, you can select any sprite to be what emits from your particles. We can select something like these cute little love hearts. So you can see we've got little hearts emitting now. We could have small versions of ourselves popping out, which is kind of weird, but could be cool and trippy, right? But yeah, there's a lot of fun things you can do with this, and there's no harm in trying. Currently in our game, we can move around inside this box. We can also jump outside our walls. First of all, I'm going to go into our scene and draw some walls around all the edges. Just make it like a box so our player can't get out. You can see we walk and we go to the edge and we see all this empty white space. That's because our camera is following our player but isn't being confined. In a previous video, we got our camera following our player by adding a Cinemachine virtual machine by going right click, Cinemachine, 2D camera, and then dragging our player into this follow slot. So if you haven't done that, that's all you need to do. To get our player confined to these walls so you don't see any blank space, in extensions on your Cinemachine, you can click on this drop down and add a Cinemachine confiner. You see there's a slot here for a bounding shape 2D. To add this, I'm going to create a new empty object, call it a confiner, then add a polygon collider 2D, then click edit collider, and you can drag these points out to the edges of your box, going just a bit over. Cool, now make sure you tick is trigger, and then we'll go back to our Cinemachine camera and drag in our confiner into this bounding shape 2D. Now when we press play, our camera still follows our player around, but stops on the edges of our box. If this feels a bit too rigid for you and you want it to have a little give when we reach the edges, on our Cinemachine confiner we have a dampening slider. If we set this to like 1 and press play, you can see now the camera gives a little and then snaps back to our confined area. This gives the game a little more flow, but it's up to you the kind of feel you're going for. By the end of this video, we'll have learned how to use interfaces to create generic items in our game and get our player to collect them with a collector. Very exciting, learning some cool code tricks. In case you haven't used them before, an interface is like a contract where you define methods that classes that use that interface must implement. In our case, we're going to create an interface for item, so anything that we can pick up. So we're going to say anything that's an item must have a collect function. The item we're going to define will be a gem, and we'll implement the item interface. So our gem must include a collect method. So we'll add collect, and in here write the functionality that collect will do for a gem. This is then handy when you have different items you want to pick up. So like when we pick up gems, it'll increase our progress. When we pick up a health item, it can increase our health, and lots of other ideas you may have for your game. But that's it. We can get started now. Cool. First of all, since we're going to add some new scripts, more than just our player movement, I'm going to create a new folder in our assets and call this scripts. I'm going to drag our player movement into that and then open up our scripts folder. I'm going to right click and create a new C# script and call this item. So let's open this up and create our interface. So for this, we don't want it to be mono behavior. It's just going to be an interface. And instead of public class, we're going to be public interface. And we won't have start or update. And nice and simple, all we need is public void collect. That's all we need for now, but if we ever wanted our items to add any more functionality, we add it in this one place and it'll be easy to update all our other items. Back in Unity, we'll create our script for our gem. So right click, create C# script, call this gem, and double click to open it up. Now in here, we're already implementing mono behavior. You can implement multiple interfaces. So you can go comma item. It has a red underline. If you hover over, you can see it's saying because we don't have our collect functionality. So what you can do, really easy, is click show potential fixes and then implement interface. This makes our collect for us. Remove start and update. For now, we'll keep it simple. So when we collect our item, we're going to destroy this game object. So when we pick up our item, it'll disappear. Cool. Back in Unity, we'll go to our player, and since we have a nice big script for player movement, we'll close this off and create a new script and call it a collector. In our collector script, we're going to use onTriggerEnter2D to see when we've bumped into an item to pick it up. First, I'm going to add another collider. So I'm going to add a circle collider 2D to our player and click is trigger. We already have a box collider 2D, but this one isn't trigger so that we can touch the ground. So we'll use this circle collider as our pickup. You can see it's quite small around our player. You could make this bigger if you want to have a bigger pickup range. I'm just going to keep it wrapped around our player for now. And there's a big gizmo on top of our player. On the top right, there's this ball looking thing with the dots. If you click on that, it hides the gizmos. So now you can see our collider. Cool, so let's open up our collector script by double clicking on it. And in here, we want to get rid of these. And we can say on trigger enter 2D. Now we're going to check if our collision is an item. To do this, we can use our item interface, which also makes it handy to keep all your items generic and pick up any without worrying about what type they are. So we'll say item equals collision.getComponent item, and we'll say if item is not null, and that means we have got an item. So we can call item.collect. And that's it, nice and simple. Now back in Unity, we can create our gem. Let's right click and go 2D object sprite. I'm just going to go for an isometric diamond. So I'm going to name this gem, and I'm going to go on add component and add the gem script. And I'm also going to want to add a so-called collider 2D. And I'm going to set this to is trigger. And drag the gem from our hierarchy over into our assets to make it a prefab. And then we can drag lots out to be multiple gems in our scene. Now when we press play and walk into our gems, you can see they're being destroyed. On our sprite renderer, I'm going to change the color. And on our gem, I'm going to go to the animation window, drag this down the bottom and click create. I'm going to go to our animations folder and call this gem. And in our sprites folder, on our Tilemap, if you open it up, just found some free gem sprites. So what I'm going to do is select all of these and drag them into our gem animation. Change the scale back to be 1 by 1. You can see it's very fast, a little too fast. So I'm going to add in the 2 more sprites of them getting smaller next to that biggest one. Select them all by doing Control A and then drag out the last one for about 1 second. Now when we press play, you can see it does this kind of, it's like, but I can't think of what to call it. You can see what it does. Now I'm just going to drag one of these into our default sprite in our sprite renderer. And you can see none of our other prefabs have changed of our gem. To get these all to update, in our inspector in the top right, you can see there's a drop down that says overrides. If you click on this and then click apply all, you can see they've all changed. And when we press play now, we got some cool looking gems, very appealing, makes me want to pick them up. Whoa, gotta get them. By the end of this video, we'll see each level's progress when our player picks up these collectibles. And we'll see this progress on the slider on the side. We're going to implement this functionality with actions and events so we get to learn something cool and new. So let's get started. So we made our gem prefabs in the previous video. All this does right now is destroy the game object when we collect it. But the plan is to use these gems as a way to track progress through our level. When we got enough gems and filled our gauge, we'll go to the next level. So let's open up our gem script, and in here we're going to add a public static event action and then pass in the type int. Make sure you have using system, and I'll name this action on gem collect. I'm also going to add a public int worth and set this to a default of 5. That way we can add different types of gems that are worth different amounts. Now in our collect function, all we'll have to do is type on gem collect dot invoke and then pass in our worth. What this does is sets up an event that other scripts can subscribe to. So when we pick up this gem, another script can handle the process of this worth. So let's write that script. Back in Unity, I'll go to our scripts folder, right click, create C# script and call this game controller. And double click on this to open it up. In here we'll add an int called progress amount, and in our start I'm going to set this to 0. So this progress amount is going to increase whenever our gem is picked up. So let's subscribe to our gem event. So call gem.onGemCollect and go plus equals, and here we'll pass in a function. I'm going to call this increase progress. This doesn't exist yet. Now I'm just going to copy this name and go void increase progress amount, and in the parameters we're going to want to pass in our int amount coming from our gem's worth. Now pretty simple, we're going to go progress amount plus equals amount. This is red and underlined because we don't need the brackets on the end, just increase progress amount. Okay, so now we're going to say if our progress amount is greater than or equal to 100, then our level is complete. This is where we'll add the functionality to move to the next level, but for now I'm just going to debug.log level complete. Cool. So now we're going to do it backwards and add the code in for our Unity slider. So if you type slider up in our variables and hover over, you can import using unityengine.ui. Then add public. So we want a public slider, and we'll call this progress slider. In our start, we'll make sure our progress slider's value is set to 0, and then every time our progress amount goes up, we're going to set our progress slider's .value to equal our progress amount. That's all the code we'll need. So let's go back and set this up in Unity. So back in Unity, right click in the hierarchy and go create empty, and I'll name this game controller, and then I'm going to drag in our game controller script into our object. Now we have an empty slot for our progress slider. So let's add this. Right click in the hierarchy and go UI slider. I'm going to name the slider progress bar, and I'm going to rename the canvas that appeared alongside it UI. And I'm going to set the canvas scaler to be scale with screen size, and I'm going to match this to my screen size. So mine's 1920 to 1080. Double click on UI in the hierarchy to zoom out and see it properly in the scene, and click on our slider, and we can move this around with the move tool. I'm going to change our scale, so X to be 5 and Y to be 3. I'm going to untick interactable and scroll down to where it says direction. I'm going to do this from bottom to top. Move this up again. I'm going to set our max value to be 100, same as how many I need for the level to change. Then in the hierarchy, you can open up the progress bar tree, and if you have the value of the slider, then go to fill area, open this up, click on fill. We can change the color of the progress bar's fill. I'm just going to match this to my gem. By default, the top and bottom are set to -5 and -5. If you set these to 0, then go to background, set these to 0, and go to fill area and set these also to 0. You won't have any weird padding around the sides. Then I'm going to open up handle slide area, click on handle, and you can change this circle to be whatever you like. I'm going to make it one of our gems. Also, this is transparent because by default, when the slider is disabled, it sets it to half transparent. So if you go back to the progress bar, click on disabled color and then up the A, alpha, and close this. And I'm actually going to change the background color to be half transparent instead. Cool, now select our game controller, drag in our progress bar, and we're all set up. When we press play and pick up our gems, you can see the progress bar going up. But at this rate, we won't be able to complete our level since our gems are only worth 5. So if we select one of our gem prefabs, I'm going to rename this one Big Gem and go to our gem script on this gem. Here we can set the worth of a big gem to something like 20. I'm going to scale it up a bit, setting it to 2 by 2 on the X and Y. Now select another gem and we'll call this small gem. I'm going to set the size to be 0.75 by 0.75. I'm going to set the worth to be 10. I'm going to right click in our main assets folder, create a new folder and call it prefabs. I'll drag in our player and go inside, and I'm going to select our big gem and drag it over to our prefabs folder. I'm going to make this an original prefab. Then I'm going to drag our small gem over and I'm going to make this an original prefab. Cool. I'm going to delete our normal gems and delete the normal gem prefab, so we just have big and small ones now. Now back at our scene, I'm going to drag a few gems over. Cool, so now when we press play, I'll pick up some gems. You can see it's going on much faster now. And when we hit 100, you can see in our console, level complete. In an upcoming video, once our slider has reached the top, we'll be able to hold down a button and load our next level. But for now, that's it. See you then. In this video, we're going to get our platforms going from this, where you can stand on top and bump your head on the bottom, to this, where you can stand on top and jump through. So in Unity, in your hierarchy, go to your tile map that has your platforms on it. For me, that's ground. Then scroll down and click Add Component and add a Platform Effector 2D. Then in our Composite Collider 2D, which we're using on our Tilemap platform, click Use by Effector. Then to make sure we don't get stuck in our platform, on Geometry type, instead of outlines, switch this to polygons. When we press play, we can still stand on top of our platforms, but if we jump off and go below and try jumping up through, we can go straight through the platform instead of bumping our head. Cool, and that's it. Our platformer has a much more fluid feel. See you in the next one, where we'll be doing level loading. Ooh. By the end of this video, once our progress bar is to the top, we'll be able to hold down E and progress to the next level and start collecting all over again. We're going to be using Unity Input System and Unity's actions and events. So let's get started. So first of all, we'll add the circle that'll appear and fill up while holding down our button. So right click on our player and go UI, Image, and call this image Load Circle. Then I'm going to rename our canvas Load Canvas. Then I'm going to set the render mode to world space, so this follows around on our player, and the camera to main camera. Then make sure your canvases transform, X and Y is set to 0 and 0, and you'll see this is way too big. So if you go scale 0.01 and 0.01 in the X and Y, we'll go to our load circle, and on source image, I'm going to click on this box, and then in the top I'm going to search for knob, K-N-O-B, and you'll find this circle. I'm going to select the color with the color picker and just select our gem so it's the same purple color. Cool, and then I'm going to move this up just above our player's head, and I'm going to set the load circles width and height to be 50 and 50. Cool, now on image type, select this drop down and select filled, and now we can see there's a radial 360 which we're going to be using. With this fill amount slider, you can drag this and you'll see this circle kind of like fills in a pie chart. I'm going to do the fill origin from the top just so it's kind of like a clock face. So I'm going to be starting at 0 and then it'll be filling in all the way to 100. Cool, so now we're going to need a script to handle this functionality. So I'm going to click on our load canvas and add a new script to this. I'm going to call this hold to load level and then double click on this script to open it up. So first we'll add a public float and we'll call this our hold duration, and I'll set this to a default of 1. So this is how long you have to hold down for before your action happens. For us, that'll be loading our next level. Then we're going to want our image of our circle. So I'm going to want to go public image and I'm going to call this fill circle. We'll want using Unity engine.ui. Then we'll add a private float for our hold timer. Set this to 0, and a private bool called is holding. Set this to a default of false. Cool, so now we don't need our start, but we will need our update. So in our update, we're going to say if is holding, then we're going to up our hold timer by using plus equals time dot delta time. Then we're going to set our fill circle dot fill amount to equal our hold timer divided by our hold duration. Cool, next we'll say if our hold timer is greater than or equal to our hold duration, then we'll load our next level. So that's what happens when we are holding, but we're not currently implementing holding yet. Currently in our game we're using Unity's input system for our movement and our jumping. We're going to create a function just like this in our script for holding. So let's go public void on hold, and we'll pass in our input action dot callback context, and we'll call this context. Then we'll say if context dot started, which means we've pressed down our button, then is holding equals true. Else if context dot cancelled, then we're going to call a function to reset our holding. So let's write that function. So we'll go private void reset hold, and we'll go is holding equals false, hold timer equals 0, and fill circle dot fill amount equals 0. Copy this function and paste it up in our else if, and now we'll hook this up to a new input in Unity. So back in Unity, in our assets, we have our player controller input system. If we double click on this, we can see our move and jump actions. We're going to click the plus on actions and add a new one called hold. Then in this no binding, we'll click on this, and on path, click the drop down, click listen, and I'm going to set this to be E. So when we hold down E, we'll go to our next level. Save this and close it off and select our player, and on our player you can see our player input. Open this up, open up events, then open up player. Now you can see our move function, our jump function, and we've got one for hold. So let's add to our hold list and then drag in our load canvas into this slot from the hierarchy into here. Then in the drop down, go to hold to load level and select on hold. Cool. Now let's click on our load canvas, and on here we need to drag in our fill circle. So that's our load circle into this slot. Click on our load circle, and so we don't have this ball on our head by default, we'll set our fill amount to 0 and then press play. Now when we hold down E, you can see this fills up. So once this is filled, we can make our level load. You can use this method in other cases, like charging a weapon or interacting with an object. But for now, let's load our levels. Let's go back to our hold to load level script, and in here, we're going to add a public static event action, add using system. I'm going to call this on hold complete. Now if we copy this, and where we want to load our next level, we're going to go on hold complete dot invoke, as we're not going to handle the loading the next level. We'll leave that to the game controller. After we invoke this, we also want to reset our hold. Cool, so now back in Unity, going to go to our game controller and open this up, and here we're already subscribing to our gem event. Underneath, I'm going to subscribe to our hold to load level dot on hold complete. We'll go plus equals load next level, which we haven't written yet. So I'm going to copy this and go void load next level. Oh, and I always do that. Don't need the brackets on the end when we're subscribing. Now I'm going to do some setup back in Unity again before we get to some more complicated code. So this is how we're going to load our levels. Currently, I have a grid of one level. Inside this, we have our ground and our wall. What I'm going to do is name this level 1. I'm going to right click and go create empty, and call this levels, and drag level 1 inside levels. Then I'm going to right click on level 1 and click duplicate. I'm going to rename this level 2. For now I'm going to click on level 1, and in the inspector there's a little tick next to the name box. If you tick on that, it'll disable level 1. We'll click on level 2 and we'll design a new level. So remember, you can go to Window, 2D, Tile Palette, and we can simply take the eraser and delete our platforms. Make sure you're on the right tile map when you're redoing this. Now I'll quickly make a new tile map. Cool, okay, now we got level 2. So you might have guessed it, but basically what we're going to do is deactivate one tile map and enable the other. Real simple method. Not everything has to be difficult. So we're going to handle this in our game controller script. So let's open that back up. And at the top we're going to want a few new variables. So we're going to want our public game object for our player, a public game object for our load canvas, a public list of game objects, we'll call this our levels, and then a private int, and we'll call this our current level index. Set that to a default of 0. Now we passed in our load canvas here, so that when our progress is at 100, we'll set our load canvas, so load canvas.setActive, to be true. We're going to have this set to false by default. In case you forget, you can put this set to false up in the start, so we make sure that's always turned off. So now down in our load next level, we're going to go int next level index, and it's going to equal, I'm going to put this in brackets, our current level index equals our levels dot count minus 1. Then outside the brackets, type question mark 0 colon current level index plus 1. Okay, so what this does, in case you've never seen this before, it's basically a one-line if statement. So we're saying if our current level index is equal to the amount of levels we have minus 1, so are we on our final level? Because indexes start at 0. Ours would be 0, then 1. So 0 for level 1, 1 for level 2, because programming is cool. So basically when we hit level 2 and we want to load our next level, if there are no more levels, we're going to set it back to 0, so back to level 1. Else we're going to take our current level index and add 1 to move to the next level. And then I'm going to set load canvas, set active to false, so we can no longer hold down to load. Cool, now we're going to disable our current level and enable the next one. So we're going to go levels, current level index, dot game object, dot set active to false. Then we'll go levels, next level index, dot game object, dot set active to true. Now when our new level loads in, we're going to want to set our player, dot transform, position back to the center of the screen. For me, that would be a new vector free 0, 0, 0, since that's my player's starting position. Then we'll set our current level index to be our next level index, our progress amount to be 0, and our progress slider dot value to be 0 as well. Cool, and that should be it. Back in Unity, we can select our game controller, drag in our player, drag in our load canvas, and then in our levels, we'll drag in level 1 and then level 2. If you open this up, you can see these have been added in order. I'm going to disable level 2 and enable level 1 and disable our load canvas, and then press play. So now if we collect enough for our slider to be full, you can hold down E, and we're in our next level. Level 2, baby! Now our slider is set back to 0, so I'll have to collect more items to get to the next level again. Or defeat enemies. Ooh. What's coming next, I wonder? In our next video, we're going to be adding enemies. By the end of this video, we're going to have this little googly guy, oh my god, get him away from me, chasing us around and jumping over platforms. Whoa, that's smart. He's a genius. So let's go. So first of all, let's right click, go create empty, and name this enemy. We'll add a component and add a sprite renderer. And in here, I'm going to select a ghoulie, an enemy sprite. Cool, so we got this cute little octopus guy as our enemy. I'm going to change his color to this nice red and close that off. Then add a new component of a rigid body 2D. In here, under constraints, I'm going to freeze his Z rotation so he doesn't spin. Then add another component of a box collider 2D so he can stand up on our platform. Just going to edit the box collider and make sure it wraps around him correctly. Cool. I'm going to add a component, new script, and it's going to be called enemy. Double click on this to open it up. Let's get our guy moving. So first, we're going to want a public transform. This is going to be our player who we're going to chase. Then we'll have a public float, which will be our chase speed. I'm going to set this to a default of 2. And then a public float for our jump force. I'll set to a default of 2 as well. Then we're going to want a public layer mask for our ground layer. We used this before for our player's ground check. We're going to use this to check where our platforms are for our enemy. Next we'll want a private rigid body 2D called RB, private ball called is grounded, and a private ball called should jump, which we'll use to tell our enemy to jump. In start, we're just going to set our RB to get component and pass in rigid body 2D. Calling get component without anything in front just calls it off of the object that it's placed on. So now this is going to get complicated, so let's plan it out. First of all, let's see, are we grounded? Next we'll get the direction of our player. Then we're going to see if our player is above us. So let's do these first before we move on. So is grounded equals physics2d.raycast, and we'll pass in, for the origin will be our transform.position. The direction, since we want to see if we're on the ground, will be a vector2.down, and the distance would just be 1.5f, and we're going to use our ground layer to check against. Actually, I'll change that to 1f instead of 1.5. Cool. Now we want our player direction. Let's go float direction equals mathf dot sign, and we'll pass in the player position dot x, take away our own transform position dot x. Well, now I have a ball is player above, and we'll set this to physics 2d dot raycast, and we'll pass in our own transform position again. This time we want a vector to up. We want to see if it's above us. We'll check within 3 units, and since we don't have a specified layer for our player, what we can do is type 1 less than player.gameObject.layer, which will get our player's layer for us. Cool. Now, if we are grounded, we'll chase our player. But first we'll do that the classic way of setting our RB velocity to equal a new vector2, pass in our direction times our chase speed, and then our current RB velocity.y. So this will just move him left or right chasing our player. Now we want to see if he wants to jump. So we're going to want him to jump if there's a gap ahead and no ground in front, else if there's player above and a platform above. So let's find out if there's ground, if there's a gap, and if there's a platform above. So all of these 3 are going to be raycast hit 2D. First one we'll call ground in front, and we'll set to equal physics2.raycast, pass in our transform.position, pass in a new vector2 for our direction, and we'll pass in direction and then 0 for the y. Since we only care about our player's x for checking the ground. The distance before we jump we can do as 2f, but you can always change this to fit with your platformer. And because we're looking for ground, we're going to want to look at the ground layer. Cool, now let's look for a gap. So we'll go raycast hit 2D, gap ahead equals physics2d.raycast. We'll add our transform.position plus a new vector 3. We'll pass in our direction and 0 and 0. Now for a gap we want to look down. So our vector 2 is going to be vector2.down. We'll do the same for a gap, so 2f. And then same as above, ground layer. Now let's check if there's a platform above. So raycast hit 2D, platform above equals physics 2D dot raycast. Pass in our transform dot position. The direction we're looking is up, so vector2 dot up To look above, we'll say free before we try jumping. And we're also looking for our ground layer. Cool, now we know all these. We can say if there's not a ground in front dot collider and not a gap ahead dot collider, then we'll set should jump to equal true. Else if there is a player above and there's a platform above dot collider, then we should also jump. So should jump equals true. Cool, so now we know when we should jump and when we shouldn't. So let's get him jumping. For that, we're going to use the fixed update method. We're going to say if we're grounded and we should jump, we're going to set should jump to equal false. We're going to get our direction to our player. So vector2 direction equals player.position, take away or minus, transform dot position dot normalized. This is so he doesn't go faster on the diagonal. Then we do a vector2 and do a jump direction. This will equal direction times jump force. Now with this, we'll go rb.add force. We're going to pass in a new vector2, pass in our jump direction dot x in comma jump force. And outside this bracket, we'll go comma force mode 2d dot impulse. Cool, and that's it. Hopefully that all made sense. Back in Unity, on our enemy script, we're going to need to drag in our player into the player's transform. And then on our ground layer, you'll need to select ground. If you don't have this ground layer, wherever you have your grid set up that's connected to your platforms, or if you're using individual platforms, add a layer to this and call it ground, or whatever you like, and make sure it's selected in this layer dropdown. It basically has to be whatever you're colliding with. And in your enemy script, make sure this is selected under ground layer. Cool, now press play. You'll see, oh my god, he's gonna get me. He jumps pretty high. Whoa. So what I suggest to help with this floaty crazy octopus is setting your gravity scale in your rigid body 2D to something a little higher. You'll see he falls a little heavier so he doesn't go flying around all over the place. Yeah, he looks pretty good. You can see that he jittered a bit when I was too high up. The checks for his platform above and player above, they're both free. If we up these, I'm going to put them to 5. Cool. So now you can see he's trying to get me, but he's too short. Obviously we can make him fly a little higher if I up his jump force. Let's see if he can make it now. Whoa, there you go. So yeah, his jump force up to 3 makes him bound a little high. That's where again you can mess around with gravity scale, mass, linear drag, angular drag, and get the feel you want. But cool, that's it. By the end of this video, we're going to get our objects randomly instantiating on top of these platforms, like our enemies and our gems. We're going to do this by passing in our tile map and checking which locations are available for our spawn points. Then when we change level, we'll remap these spawn points and continue our game. This script is quite long and complicated, so if you do feel like being lazy but also supporting the channel, you can check it out on my Patreon, as well as all other scripts on this channel. So right now in our scene, we have these placed gems and enemy. We're not going to need these anymore. I'm just going to untick them for now so they disappear from our scene, and instead we're going to randomly instantiate these. My levels are made up of grounds and walls. So with this script, what we're going to do is pass in this ground tile, so then only these tiles will have gems or enemies appear on top of them, so we don't get gems and enemies appearing in random places. So first I'm going to make a new game object and call this object spawner. I'm going to add to this a new script and call it object spawner and open this up. First I'm going to set up all the variables we need. So first we'll do a public enum called object type, and we're going to have a small gem, a big gem, or an enemy. You can keep adding to this list if you want more items in the spawner. Next we'll need our public tilemap, which I'll call tilemap. We'll need using Unity engine tilemaps, and we'll want an array, so a public game object array of our object prefabs. Then we're going to want a float for the chance of spawning a big gem, which I'll call big gem probability, and I'm going to set this to 0.2. So we'll have a 20% chance of spawning a big gem. Then we'll do another one for our enemy probability, which we'll do to 10%, so 0.1f. Then for the spawner, I'm going to want a max amount of objects, and then when it hits that point, it'll stop spawning. Oops, so that's a public int max objects, and I'll set that to 5. And then I'll do a public float gem lifetime, which I'll set to 10, which means after 10 seconds our gems are going to fade away and we won't have this affect our enemy. And we'll do one more float for our spawn interval, and I'll set this to 0.5f. So every half a second we'll pop something in. Now I want some private variables. So I want a private list of vector free, and this is going to be our valid spawn positions. And we'll set this to a new list of vector free. Then we want a private list of game objects, and this is going to be for our spawned objects, so we can go back to them. New list of game objects. And then we'll want a private bool called is spawning. We'll set that to a default false. Cool, so that's our variables. So first of all, in our start, what we're going to do is have a function to gather our valid positions. So where can we spawn our items, which we want to be on top of our tile map. So let's write a function for this. So we'll go private void gather valid positions. First off, we're going to go valid spawn positions dot clear, just in case we've moved level and our platforms have changed. We want a clean slate each time. Now we're going to grab our cells bounds from our tile map. So we're going to go bounds int, we'll call it bounds int, equals tile map tilemap.cellBounds. What this does, as the tooltip says, is returns the boundaries of the tile map in cell size. So basically we're getting the shape of our tile map. Next we're going to want a tile base as an array. I'm going to name this all tiles. And we set this to tilemap.getTilesBlock and we pass in our bounds int. Next we're going to want a vector free called start. So we go tilemap.cell to world, pass in a new vector free int. Then we're going to want our bounds int dot xmin and then our bounds int dot ymin and then 0 for our y. And I didn't put this in brackets. We need another bracket on the end. Cool, now we got all our tiles. We want to loop around these. So we're going to go for int x equals 0, x is less than bounds int dot size dot x and colon x plus plus. And inside here, if you copy this for loop, paste it inside itself, and we're going to replace the x with a y. So we go around both our x and y at the same time. And what we're going to do is get our tile base, call this tile, in equal all tiles. And we'll grab the right tile by doing x plus y times bounds int dot size dot x. This grabs us the right tile. And just before we do anything, we're going to go if tile is not null, we'll say vector free place equals start plus new vector free. We'll pass in our x plus 0.5f, just so we're never right on the edge of a platform. It gives it a little breathing room. And then we'll pass in y plus 2f. So this means it will be floating just a bit above our platform. And then we'll pass in 0 for our z. And then we'll go valid spawn positions dot add this place. So we found a valid position to put something on. So basically we're looping around our x and our y. If we find a tile within this x and y, then we say this is a valid place. So now we can take this function and in our start we'll call gather valid position. So next what we want to do is spawn our objects. Since I want objects to appear over time at certain intervals, it's the perfect time for us to use a coroutine. So before our main spawning function, I'm going to write a private I enumerator and call this spawn objects if needed. In here we'll go is spawning equals true. Then we're going to want to say while however many active objects we have is less than our max objects variable, so 5, then we'll spawn an object. To find out how many active objects we have, I'm going to write a new private int called active object count, and in here we're going to go spawned objects dot remove all, so item equals greater than item equals null. So this is basically saying remove any items that are null. Then we're going to return our spawn objects dot count. Now we can call this function in our while loop. So while active objects count is less than max objects, we're going to spawn our object. In between spawning our objects we want to wait, so we'll go yield return new wait for seconds, and then we'll pass in our spawn interval. And then at the very end we'll go is spawning equals false. Cool, so now we're going to want a spawn object function. But first of all, let's go to our start and just go start coroutine, pass in our spawn objects if needed, and that's our start all done. Okay, so now comes the beast. Okay, so we're going to go private void spawn object. We'll say if our valid spawn positions dot count equals 0. We can actually keep this in one line and just go return. Else we're going to make a new vector free called spawn position for our final spawn position. We'll set this to a default of vector free dot 0. Then we'll say bool valid position found equals false. What we're going to do is have a while loop. While not valid position found and valid spawn positions dot count is greater than 0, then we'll go int random index equals random dot range, and we'll pass in 0 to valid spawn positions dot count. We're going to get a random position from our valid spawn positions. Next we're going to set a vector free called potential position and set this to our valid spawn position of our random index. So the reason I'm calling it potential position is because I'm going to get a vector free of the left position, which is going to be our potential position, plus a vector free dot left, and then I'm going to duplicate this code down, replace left with right, and check our right. So we're looking left and right. And what we're going to do with these positions is use them to check beside us and make sure there's not another object spawned right next to us. This stops all our gems from clustering in one area. So above this function we're going to want a new one. That's a private bool called position has object, and we're going to pass in our vector free position to check. In here we're going to return our spawned objects dot any, and in our any we'll pass in check obj equals greater than check obj and vector free dot distance, and in this distance we'll pass in our check obj dot transform dot position, and then pass in the position to check. And outside of this bracket go less than 1.0f. So that big long check, it's got a squiggly underline because we need to use system link this works. You probably know what this means, but we're basically checking a padding of 1 unit to whichever direction we're passing in. So if we copy this function, we can say if not position has object, and pass in our left position, and not position has object, and then pass in our right position. Then we know we've got a nice clear spot. We're going to go spawn position equals potential position, and then valid position found equals true. And that'll break us out of our while loop. Because we're happy with this position, we're going to take it. We're going to go valid spawn position dot remove that, and then pass in our random index so no one else can use it. So now if we have a valid position, we're going to type object type, call this object type, and we're going to get a random object type from our enum to know which object to instantiate. So let's scroll up and write another new function. We'll go private object type. We'll call this random object type. And in here we're going to go float random choice equals random.value, which gets us a value between 1 and 0. So we use 1 as 100%. Then we'll say if our random choice is less than or equal to our enemy probability, then we'll return object type.enemy. Else if our random choice is less than or equal to, and I'll put this in brackets, our enemy probability plus our big gem probability, then you guessed it, we'll return our object type.biggem. Else we'll simply return our small gem. Or we can copy this function and set our object type to be our random object type. Now we'll say game object chosen prefab equals our object prefabs, and then we'll pass in square brackets and then also normal brackets. Int outside those brackets we'll say object type. Cool, so now we can go game object and equal this to instantiate, and then inside here we want to grab our prefab using this type. So we're going to go object prefabs square brackets and then curly brackets, pass this to be an int, and then we'll say object type. So this gets us our object from our array of this type. Then we'll want our transform to be our spawn position, and then we just pass in quaternion identity, which is its rotation. Now that's spawned, we want to add it to our spawned objects list. So spawn objects.add game object. Now we want our gems to be destroyed after a certain amount of time so that they keep moving around the place. So we're going to say if our object type does not equal object type.enemy, then we're going to start a coroutine of a new function that we haven't written yet, but we're going to destroy our gems after a certain amount of time. So just below this, we'll go private I enumerator, call this destroy object after time. And we're going to pass in our game object, call it game object, and then a float for our time. And what we're going to do is yield, return, new, wait for seconds, pass in our time, and then we'll say if we still have our game object, because of course we may have picked up this game object by now, and it be destroyed by us collecting it. We'll say spawned objects dot remove this game object, then valid spawn positions. We're going to add back in our game object dot transform dot position, and then we'll destroy our game object. Cool, so in our start coroutine just above, we'll pass in our destroy object after time, pass in our game object, and then we're going to pass in our gem lifetime. Cool. Let's take our spawn object function. We need to paste this up in our spawn objects if needed. Okay, so that's what happens when we start. So if we go back into Unity, we can set this up. You need to drag your ground tile map into the object spawner and then pass in your free object prefabs. So we've got our small gem, our big gem, and our enemy. Remember, this order matters since it needs to match with your enums. So make sure you have them in the right order. You can drag them around with this little bar. If we press play, we can see our items slowly spawning in. We actually have an error on our enemy right now, which we'll fix in a second. But you can see our gems spawn in, but they don't come back. That's because we got it working for start, but we still need to do some work in our update. But first of all, let's fix our enemy so he actually chases us. So in our scripts, if we double click on our enemy, right now we pass in our player transform. Instead, since we're instantiating him, let's make this a private transform. And we'll set player to equal gameObject.findWithTag, and then we'll pass in player. Then we'll go .get component and pass in transform. Now even instantiated enemies can pick up our player and pick up the transform so we can chase them around. You need to make sure your player is tagged as well. So back in Unity, if we select our player and in tag, you can see there's a player tag already for you. So there we go, our enemy now follows us. Oh, 2 of them. So yeah, you can see they're spawning in. Our enemies obviously aren't being destroyed because we didn't want that to happen, but our gems aren't coming back. So we need to edit our update function. So let's go back to our object spawner script. And in update, we want to say if we're not spawning, so if is spawning, and our active object count, which is our function we wrote below, is less than our max objects. We'll go start coroutine, same as above, spawn objects if needed. Cool, and that's all we need for our update to work. So if we go back and press play, we can now see our objects appearing. If I pick one up, nothing happens. Now I was going to say, when we go back here, you'll see when I pick up an item, it'll spawn new ones, but it's not doing it. So we have a bug. Instead of quickly fixing it, I'm going to go through debugging with you. So what we're going to do is press play. I'm going to pick up an item. So now I've got 2 gone and 3 still active. If I go to my script now in Visual Studio and click this play button on attach to Unity, now what I want to see is why we're not spawning. So if we go on our update, if you click right on the side here in this gray area, it'll stick a breakpoint in. We've hit our breakpoint because we're always going around this if statement. Now, active object count, let's check that's returning the right thing. So if we go inside here, we can see we're going to remove any objects that are null. There should be 2 that are null, so there should be 2 that get removed. If we check, our count is still 5, which is our max objects. So that's why we're not spawning any more objects. So something's happening where these aren't being removed. We can check inside, we can see there are 2 that are null. So I don't know if you've spotted the problem yet, but I didn't put 2 equals. What I really needed to do was say, is our item equal to null? I just said, item equal null. And that's how bugs are formed. Hopefully that was interesting for you to see, but yeah, if we go back to Unity now and press play again, now when I pick up an item, you can see a new one is spawned and replaces it. So we always have 5 items, or enemies. You can see I've picked up enough to move to the next level in our bar here. So let's see what happens when we move to our next level. We do this by holding down E. We can see our gems aren't positioned on the right place. They're appearing where our old platforms were on level 1, not for level 2. This is because when we change level, we don't do anything to get our new valid spawn locations. The way we're currently changing levels is by deactivating level 1, and then we reactivate level 2. If you change scene and add in this object spawner, it should just get your valid locations for you. But for us, we're going to go into our script, and in our update at the top, we're going to say if not tilemap.gameObject active in hierarchy, and it's been deactivated, so our level has been changed. We're going to call our function called level change. We can write this just below and go private void level change, and then we're going to need to find our next tilemap. Tilemap we want is inside our levels, and it's called ground. They'll always be the same name. This is important for this to work. So make sure we're also the same, because what we're going to do is say tilemap equals gameObject.find. We're going to pass in ground. So we're looking for a game object called ground, and then we're going to get the component and get the tilemap. We're then going to call gather valid positions, our function from the beginning. And then what we need to do is destroy all our spawned objects so they don't come with us to the next level. So let's scroll down to where we destroy our objects, and we'll go private void and call this destroy all spawned objects. And we'll simply go for each game object called obj in our spawned objects. If our object is not null, we can destroy obj. And then our spawned objects dot clear. So we clear our list after destroying our objects. So we'll go back to the top, and then under gather valid points, we go destroy all spawned objects. Now our level change function is done. We can put that back up in our update. And I just made another mistake, but in this for each loop, this spawned objects dot clear, we don't want inside the for each, we want it outside. Just make sure your prefabs positions are all set to 0, otherwise they'll be instantiating at random floating places like this enemy and just more gem. And I've actually changed, you know where I said you could mess around with your X and Y padding here? I changed mine down to 1.5 from 2 in gather valid positions. So you can change this too after testing out what you see is best for yours. But yeah, our gems on the bottom float a little higher just because the sprite that we're using is smaller than the thick platforms above. So this is something to keep in mind as well. I think we got enough enemies here. Quick, change level. We can see now when we change level, our gems are positioned nicely on top of these platforms. Look at that one beautifully sitting on top. Ah, that looks nice. Obviously you can edit this as much as you like to be the kind of thing you're looking for your game. But yeah, this is what I wanted for this platformer. In our next video, we're going to get our player hit. We're going to hit our player. We're going to make it so when our enemies touch our player, we actually take damage. By the end of this video, we're going to add hearts to our player's UI. And then when we get hit by an enemy, our health's going to go down and our player's going to flash red. In the future, we're going to add the game over screen. But for now, let's keep it simple. So in our game, we have this section for UI. If I open this up, you can see this is where our progress bar is kept. We're also going to put our health bar in here. So I'm going to right click and go create empty and call this heart container. Then on this, we're going to click add component and search for a horizontal layout group, and we can leave this with child alignment upper left. Then I'm going to right click on our heart container and go UI image. Then I'm going to select a heart image and make this red. And I'm going to name this heart prefab. We can now see our horizontal layout group at work. If you copy and paste your heart prefab a few times, you'll see these appear in a horizontal line instead of stacking on top of each other. If we double click on our heart container, we can select the move tool and move this up to the place that we want it in our game. Our UI here is a canvas. We've got it set to scale with screen size and set to our target resolution, which I have as 1920 by 1080. You can see this is also in our game view to make sure when we change our heart container in this view, it'll be the same no matter what screen size you have. Cool, so now with our heart container selected, I'm going to add a new script and call this health UI. Now we can double click to open it up. So the variables we'll want is a public image, which we'll import in using unityengine.ui, call this heart prefab. Then we'll want a public sprite called full heart sprite, and then another public sprite for our empty heart sprite. Then we're going to want a private list of images, and we'll just call this hearts. We'll set this to a new list of images. Now we don't need start or update, but we will want a public void set max hearts, and we'll pass in an int of max hearts. Then to clear up our previous max health, we'll go for each image heart in hearts. We're going to destroy that heart.game object. Then we'll go hearts.clear. Then we'll do a for loop of int I equals 0 and I is less than max hearts colon I plus plus. So for each heart in our max hearts, we're going to go image new heart equals instantiate heart prefab, comma, transform. This transform sets the parent of our heart prefab to be our heart container. Then we'll go new heart.sprite equals full heart sprite. We'll go new heart color equals color.red, and then we'll go hearts.add new heart. So I'll add this to our list. Next, we're going to want another public void, and this time it's going to be called update hearts. And in here, we're going to pass in an int of our current health. Then in here, we're going to have another for loop. So I'm just going to copy the one from above and paste it here. And instead of less than max hearts, we're going to go hearts.count. So for each one of our hearts, we're going to say if I is less than our current health, then hearts, square brackets, I.sprite equals our full heart sprite, and our hearts, square bracket, I.color equals color.red. Else, we've been hit, so we want an empty heart. So if we copy this from above and instead set the sprite to be an empty heart sprite and set the color to be white. Cool, and that's it for the health UI script. So back in Unity, we'll go to our prefabs folder and we'll drag through this heart prefab from the hierarchy into our folder, and I'll delete these 3 heart prefabs we have in our heart container. Select our heart container and then drag heart prefab into this slot. Then for the full heart sprite, I'm going to select the same heart that we used before. I'm getting these from the Tilemap in Kenny Games, which I have linked below. And then the empty heart sprite, there's another heart on this Tilemap just before the first one of a smaller heart, which we'll use for our empty heart sprite. Now our UI is set up, we can go to our player, and on here I'm going to add a new component and add a new script and call it player health. And I'm going to double click on this to open it up. First we'll want a public int for our max health, which I'm going to set to a default 3. And then a private int for our current health. And then we'll add a public health UI for our health UI. First of all, in start, we want to set our current health to be our max health. And then we'll go health UI dot set max hearts to our max health. We can get rid of our update function, and instead we'll go on trigger into 2D because I use a trigger collision for our enemies hits. We'll go enemy equals collision dot get component and pass in enemy in here. And we'll say if enemy, so if we have an enemy object, which means we did collide with an enemy, then we're going to take damage. We haven't written this take damage function yet. So down below, let's go private void take damage, and then we'll pass in an int damage. Then we'll go current health minus equals damage. Then we can use our health UI and call update hearts and pass in our current health. And then we'll say if current health is less than or equal to 0, our player is dead. So here we'll call game over or do some animations and anything else that happens when your player dies. We'll take a look at that in a future video. But for now we can see our take damage function wants an int of damage that we want to hit our player with. Right now our enemy doesn't have a damage variable on it. So if we hold down control and click on enemy, we can go to our enemy script, and in here we can go public int damage and set this to a default of 1. Back in player health, we can now go enemy.damage and pass that into our take damage script. Cool, so now back in Unity, we'll go to our player, and in here you can see we need to pass in our health UI. So that's on our heart container, so let's drag that from our hierarchy into our script, and then press play. Now you can see we've got our 3 heart containers at the top. You can see we got hit 3 times. Because it's so fast and difficult to see, let's add an effect of flashing our character red whenever we get hit by our enemy. So in our player health script, after we take damage and update our hearts, let's get our character to flash red. To do that, we can use a coroutine, since we want it to flash for an amount of time and then go back to our normal color. So go private I enumerator, and we'll call this flash red. What we want to do is grab our player's sprite renderer and set the color to be red. Since we'll be hit over and over, we should store our sprite renderer at the top in a variable. So let's go private sprite renderer and call it sprite renderer. And then in our start, we'll go sprite renderer equals get component sprite renderer. This will grab our sprite renderer from the object this script is attached to, which is our player. Now we can use this down below and go sprite renderer color equals color.red. Now let's get it to stay red for just a short amount of time. So we'll go yield return new, wait for seconds, and we'll pass in 0.2f. So after that amount of time, we can grab our sprite renderer.color and set it back to white. Also now with this, up in our take damage, we can go start coroutine, then call flash red. Cool, and that's everything we need. Let's go back to Unity and press play. Now, when an enemy spawns, oh, there he is, and we get hit, you can see we flash red. You can also see our hearts are going down. Obviously right now, we lose our health and we don't die. So in the next video, we're going to be adding a game over screen and a retry button. By the end of this video, when our player loses all of their health, time will pause and our game over screen will appear. It'll state how many levels we've survived through and then give us a retry button that when we press, it'll load our first level again and reset all our progress. Cool, let's go. So first of all, in our UI object in our hierarchy, I'm going to right click and go create empty. I'm going to call this game over screen. Then I'm going to right click on our game over screen and go UI text and import text mesh pro essentials. This happens when it's the first time you're using this text mesh pro. So we can close that off after importing. I'm just going to rename this game over text. And in the text box, I'm going to put game over. I'm going to set the width something big, to like 1000. I'll center the alignment and I'll set the font size like 100. I'm going to make this bold. Then in our scene view, I'm going to click on the move tool, double click on our game over text, and I'm going to drag this up to be above our player. I'm going to copy this game over text and paste it below. I'm going to rename this survived text. On here, we're going to say in capital letters, you survived star levels. I'm going to make this font size to 70 and then position this just a bit lower. So in here, we're going to replace this star with how many levels we've survived. Next, I'm going to right click on our game over screen and go UI button. I'm going to make the height 100 and the width 250 up in our buttons transform. I'm going to drag this to below our player, change the color to be a nice green, and I'll rename this retry button. Then you can open up your button in the hierarchy over here and select the text below. Then I'm going to change this text to be retry, change the font size to be 70 and make it bold. I'm going to change the color to be pure black, and I'm actually going to change the game over text color as well and change it to match. You can select from the prefab. You can actually select anywhere on the screen, which is kind of cool, but I'm going to select the same color as our enemy and be this nice red. Cool, so that's the UI I'm going to use. So now let's set up actually calling our game over screen. So right now on our player, we have a player health script. If we open this up and take a look, this is where we take damage, and in here we have a if our current health is less than or equal to 0, then here is where we're going to call our game over screen. But since it doesn't make much sense to have the code in here handling UI, I'll instead handle this in the game controller. But so our game controller can know when we die, we're going to set up an event. So at the top, we're going to go public static event with a lowercase e, and then action with a capital A. We'll call this on player died. Hover over action and do show potential fixes, and we're going to need using system for this to work. Now, if we copy on player died and paste it down where our player dies, we can go on player died dot invoke. Also know back in Unity, where I'm actually handling our UI currently and our level changing is in our game controller. So I'm going to double click on our game controller script, and in here we can see we're already subscribing to some events. So underneath these events, I'm going to go player health on player died, go plus equals, and we'll call our game over screen function, which we haven't written yet. So let's go void game over screen, and we're actually going to add some new variables now. So at the top, we're going to go public game object game over screen, public tmp underscore text survived text, and hover over this tmp text and use using tmp pro. Then we're going to want a private int for survived levels count. Also now in our game over screen, we're going to want to go game over screen dot set active to true. We'll set our survived text dot text to equal double quotes you survived. Then we'll go space plus survived levels count, then plus double quotes levels. Now if we imagine this, if we don't survive any levels, it'll say you survived 0 levels. That sounds fine. If we survived 1, it'll say you survived 1 levels. That doesn't sound fine. So instead of saying levels at the top here, take away that S and say if our survived levels count does not equal 1, then our survived text text will plus equal double quotes capital S. At the top of our screen in our start, I'm also going to go game over screen, set active to false, and then we'll go back to Unity. And if we select our game controller, you can see we need to pass in our game over screen, which is going to be this overarching container. And then we need our survive text as well. So we'll drag these into our game controller script. Now when we press play, if we get hit by our enemy 1, 2, 3 times, we've got our game over screen popping up. Back in our script, when we do actually survive a level, we need our survive levels count to go up. We handle this in our game controller script anyway, where we move to our next level. So when we go load next level, at the bottom we can go survive levels count ++, and this will just increase this count by 1. So now if I pick up some gems and go to the next level, then get hit by our enemy 3 times, you can see we survived 1 level. Now our retry button still doesn't do anything. So let's add in this functionality. So in our game controller script, we're going to go public void reset game. In here, we're going to want our game over screen dot set active to be false, our survived levels count to equal 0, and then we're going to want to load back to our first level, so level 0. Currently we only have 1 load next level where we just increase down our list of levels and then repeat back to our first one. I'm going to edit this and write a new function, so void load level, where I'm going to pass in an int of the level that we want to go to. Then I'm going to cut everything up to our int next level index and paste it into our load level script. I'm going to use level and replace the next level index with level, and then in load next level we're going to go load level and pass in next level index. Now we can reuse this code for both loading our next level actually in the game, and then also for loading our first level when we reset our game. So what we can do now is go load level 0. But when we reset our game, we don't want our survived levels count to increase. So what we can also do in our load level in our parameters is go comma ball once survived increase. Then copy this and at the bottom go if once survived increase, and then leave our survived levels count. So in our reset game, we want to go load level 0, comma, false, since we don't want this to increase when we reset our game, and then we'll set it to true in our normal loading levels. Cool, so if we go back to Unity, we click on our retry button in our UI. In the on click, you select the plus, and then drag in our game controller into this slot. Now in this no function drop down, you can go to game controller and then reset game. If we press play now and get hit by an enemy 3 times, we can then click retry and we can play again. So you can notice there's a few things that happen. Our health still stays at 0 and our objects don't despawn. So what we're going to do is go back to our game controller script, and we're going to create an action inside our game controller to tell our other scripts when our game has been reset. So we're going to want another public static event action, and we'll call this on reset. So we can go back to our player health now, and in here we'll go game controller dot on reset plus equals reset health. Then we'll write this reset health function. So we go void reset health, and in here we want to set our current health to equal our max health, and then we can go health UI dot set max hearts back to our max health. Now you may notice this is the same as the code above in our start function. So what we can do is just copy reset health and replace that up here in our start as well. Tidied up our code. Cool, so we're subscribing to this on reset, and when this happens we're going to reset our health. The next thing we needed to do was to get our objects to clear out when we change level or reset back to our original one. So back in Unity, we have an object spawner, which spawns our objects for us from a past video. If we open this up, in our start, we can go game controller dot on reset and go plus equals level change. Now level change is called whenever we change a level, but we can force this to get called, which will select our ground tile map, gathers all the new valid positions for items, and it destroys all our spawned objects. So this should fix any other problems we have. Cool, so now we're subscribing to this event. What we actually forgot to do was back in our game controller. When we press reset game in our reset game function, we need to go on reset dot invoke. Now everything should work. So let's go back to Unity, press play, and when we get hit 3 times by our enemy and press retry, our objects are destroyed and our health goes back to full. If we switch to a new level and get hit by an enemy 3 times, then click retry, you can see we go back to our first level, our objects are despawned, and we can go all over again. Now there's one last problem. When our game over screen does pop up, we can still move around. So when the game pauses, we're going to want to pause time as well. So back in our game controller script, this is pretty easy to do. All you have to do is in our game over screen, go time.timescale equals 0. This pauses your game for you. Now when we reset our game, we want time to move again and our game to be unpaused. So we go time.timescale equals 1. And that's it. So for our final test, if we get hit by our enemy 3 times, we pause in our game over screen. We can press retry and start all over again. So now we get this cool little freeze frame. And that's it. In our next video, we're going to make it a little more fair on our guys. What we're going to do is get our player shooting bullets at our enemies, where we'll shoot to harm octopuses and only octopuses. By the end of this video, we're going to get our players shooting towards our mouse direction and hitting our enemies. When our enemies have been hit 3 times, they'll die. Our enemies will also flash when they get hit. So first of all, let's get our player shooting. If we select on our player and click Add Component, then New Script, I'm going to add a new script called Player Shoot. Double click on this to open it up, and in here the only variable we're going to need is a public game object of our bullet prefab. And we won't need our start function. In our update, we're going to say if input.get mouse button down, then pass in 0, then we're going to call a shoot function. So let's write that shoot function. We'll go void shoot. And first of all, we're going to get the mouse position since we're going to shoot in the direction our mouse is pointing. So we'll go vector free mouse position equals camera.main.screen to world point, and then pass in input.mouse position. Then we're going to get our shoot direction. So we're going to go vector free shoot direction equals, and then I'm going to put this in brackets and go mouse position, take away transform dot position. So the mouse, take away our transform position dot, and then outside the brackets go dot normalized. And we're going to shoot our bullet. So we're going to go game object bullet equals instantiate bullet prefab. Transform is going to be our transform dot position, and then we're just going to pass in quaternion dot identity. I can never say that word. And then we're going to go bullet dot get component, then pass in rigid body 2D. So get our bullets rigid body 2D, and then go dot velocity and set the velocity to be a new vector 2. Then we're going to want it to move in our shoot direction dot x, comma our shoot direction .y, and then you're going to times this by the speed you want this to go at. So we could actually put this in a public float called bullet speed at the top, and I'm going to set this to a default of 50. I want my bullets to go quite fast. So then you go times bullet speed at the bottom there. Cool, and that's everything we need to get our bullets shooting. So back in Unity on our player, you can see there's a slot here for our bullet prefab. In the hierarchy, if we right click and go 2D object, sprites, circle, and then name this bullet. On our transform, I'm just going to set this to 0.5 by 0.5 in the X and Y. Going to add a circle collider 2D and set to is trigger, and then we'll want a rigid body 2D and set our gravity scale to 0. I'm also going to select a different sprite, one from our Kenny Games assets Tilemap. It's a nice little circle one right at the very beginning. So we have a tiny little bullet. I'm going to drag this bullet from the hierarchy into our prefabs folder, and then click on our player and drag our bullet prefab from the folder into our player shoot script. I'm going to delete this bullet in the hierarchy, and cool, if we press play now, we can test this out by clicking. Cool, those bullets are shooting fast. You can see it's going wherever my mouse is, so I'll move my mouse to the left. You can see it shooting towards my mouse there. To the right. Now we're not currently doing any damage to our enemy. So if we click on our bullet prefab, we can go add component, new script. I'm just going to call this bullet. Now we can double click on our bullet script to open it up, and at the top we're going to want a public int called bullet damage. I'm going to set this to a default of 1, and we don't want a start or a update, but we want a on trigger enter 2D, and we're going to go enemy equals collision dot get component and pass in enemy, and say if we got an enemy, so if enemy dot take damage. That's where we're going to hit our enemy, but our enemy doesn't currently have a take damage function. Under this, we're going to want to destroy this game object, so this will be destroying the bullet after it hits our enemy, so it doesn't just keep flying around. Back in our player shoot script as well, so our bullets don't just last forever after we instantiate them. At the bottom here we can go destroy bullet and then pass in a time frame. So after this amount of time we're passing in, our bullet's going to be destroyed, just in case they don't hit anything to destroy them themselves. So this will be after 2 seconds our bullet would disappear. Cool, but now back to our bullet script. We want our enemy to take damage. So if you press down Control and then click on enemy, it'll take you to your enemy script. Our enemy doesn't currently have any health, so let's go public int max health, set this to something like free. We'll want a private int current health, and I'm also going to add a private sprite renderer called sprite renderer. Because just like we did with our player who flashes red when he gets hit, I'm going to get our enemy to flash white when he gets hit, so we have a visual representation. So now in our start, we're going to go sprite renderer equals get component sprite renderer and set our current health to be our max health. Then down the bottom, we're going to make a public void take damage and pass in an int of damage. Also in here we're going to go current health minus equals damage. Then we'll say if our current health is less than or equal to 0, we will die. So let's write this die function. So void die, and we're going to populate this a bit more later in our next video, where we're going to be making a loot table for our enemy to drop items. For now we're just going to call destroy game object. Cool, now we said we wanted to make a flash when he gets hit. So under where he takes damage, we're going to go start coroutine flash white. and this is the function we're going to call. So another new function. This one we want to be a private eye enumerator, so we can put it in a coroutine and call it flash white. For this one, our enemy actually has a custom color. He's not just a standard red or white. So what I'm going to do is grab his color before he gets hit. So I go color equals sprite renderer dot color. Then we can set our sprite renderers dot color to be white since he's currently red. It'll look like a flash. Then we want to yield return new wait for seconds and wait for 0.2f, and then we're going to set our sprite renderers color back to be the original color. So I'm actually going to call this OG color, place that down the bottom, and I'm going to set this up in our start, so we're not setting this every time we get hit. So if I scroll up to the top, I'm going to instead make this a private color called OG color, and we can't set this in here, so I'm just going to copy this, put it in our start, and then delete this equals setting bit. Cool. Now down the bottom, just remove this color variable so that we're using the one at the top, not setting a new one each time. Oh, and we don't need to set it here, we've got it set in our start. Okay, cleaned up the code. But cool, that should be everything we need. If we go back to our bullet, we can see we've got our enemy dot take damage, and we're not passing in any damage yet. So we want to pass in our bullet damage. And there we go. If we go back to Unity and press play, now we can, oh, he died in one hit. Okay, back in our script. You may have seen me make this error, but I said if the current health is greater than or equal to, then we die. We want to say if the current health is less than or equal to 0, of course. You may have noticed that when I did it. Okay, cool. Now when we press play, you can see we hit him once and he flashes white. He sets back to his nice red color. Oh, and I'm missing. Hit him again, and this should be it. If I can hit him one more time. He's dodging. There he goes. So he dies on the third hit there. But yeah, in our next video, when our enemy dies, we're going to set up a loot table, adding our big and small gems. Oh, that looks brutal. He's inside my body. So yeah, in the next episode, we're going to be adding some big and small gems to our enemy's loot table. And then in the video after that, we're going to add health items, which our enemies will be able to drop and make this game not so impossible. By the end of this video, we're going to create a serializable class for our enemies to be able to have loot tables. So enemies will have random chances of dropping different types of items at set values. Pretty cool, let's check it out. So currently in our game, we can shoot 3 bullets and our enemies die, but they don't drop anything for our player. So what's the point? So if we click on our enemy and then double click on our enemy script, we can see what currently happens is we take damage and we destroy our game object. So instead, what I want to do is create a loot table, which we can then pull down in our die function, and we'll go around our loot table, and before we're destroyed, we'll spawn an item. To create our loot table, I'm going to create a new serializable class. So if we go back to Unity, and in our scripts folder, I'm going to right click and go create C# script, and I'm going to call this a loot item. I'm going to double click on this, open it up, and then above loot item and mono behavior, I'm going to go square brackets system.serializable, and I'm going to delete mono behavior, and I'm going to delete this start and update, because we just want this to be a serializable object that we can call and use in other places. You'll see what this does as we go through, so I won't bother explaining it now, but we're going to want a public game object, and that's going to be our item prefab. So that's going to be what we're going to be spawning into our game. Then we're going to want square brackets range from 0 to 100. Then we're going to say public float drop chance. So we're going to have a drop chance between 0 and 100%. Cool, so that's all we need in here. If we go back to our enemy script now, so up in the top where we want our loot table, I'm actually going to add a header and call this loot, so that in our UI this looks nicer. And then I'm going to add a public list of our loot item, and I'm going to call this loot table. We'll set this to be a new list of loot item. Cool, now we can copy our loot table and take it down to our die function. So we want to go around our loot table. So we'll go for each loot item of loot item. In our loot table, we're going to say if random dot range, and then pass in 0 to 100 f. Now it's to be 0f, 100f. Is less than or equal to our loot item dot drop chance. Then I'm going to call a function called instantiate loot. I couldn't think of what to call it. And I'm going to pass in our loot item dot item prefab. So now let's create this function. We'll go void instantiate loot. We'll pass in our game object, and we'll call this loot. We'll say if loot is not null. Actually, instead of saying that, you can just say if loot to make sure it's not null. Then we'll go game object dropped loot equals instantiate loot. Position is going to be our player's transform.position, comma quaternion identity. And then since we're currently randomly spawning our purple gems around anyway, so that we can see these nicely, I'm going to set our dropped loot dot get component and grab the sprite renderer, then go dot color, and I'm going to set this to equal red. So when our enemy drops some loot, it's going to be red. Cool, so now back in Unity, we click on our enemy, we can now see we've got this loot table and loot section. In here we can add some elements, and if you open these up, you can see there's a slot for item prefab and a slider for drop chance. So if I go to our prefabs folder, I can drag in a small gem into the top and then a big gem into the bottom, and I'm just going to set the drop chance of the small one to be 80 and the big one to be 20. Cool, so when it goes around our for each loop, saying that I've actually missed something. So back in our script quickly, what we've currently got is it would go around every item and drop multiple items if the chance hits. What we want it to do is if it does drop a small one, we want it to break out. Unless if you want many items to drop, you can keep this loop going, but for my game I'm going to have it break out, so it only drops one item if it does drop an item. Cool, so now if we press play, I can attack our enemy. And he dropped a gem. You can see our gem is red where our other gems are normally purple. Now I can pick this up and it'll act just like a normal gem, increasing our progress. We have 80% chance of getting the small one. If we don't get that small one, we'll then have a 60% chance of getting a big one, since it seemed a little low to get nothing. There we go. Now we got a small gem coming from that guy. But yeah, cool. All done. Hopefully that was fun. In our next video, I'm going to add health items that drop from our enemies so that when they hit us, we actually have a fighting chance. By the end of this video, we're going to add health items to our game. So when we kill an enemy, we'll be able to pick up the health item and replenish our health bar. We're going to be adding this health item to our existing loot table from our enemy. So you can check that out if you're interested. Or check out my Patreon that includes all scripts and files from this series. Exciting. Let's go. So in our previous video, we created this loot table where we can add different percentages for different items to be dropped from our enemies. I'm now going to create a new item which is going to increase our player's health. So in the hierarchy, I'm going to right click and go 2D object, sprite, circle, and I'm going to call this health item. In our sprite renderer, I'm going to select a nice heart sprite from our Kenny Games Tilemap and change the color to be red. Cool, now I'm going to add a circle collider 2D so we can pick up our item, and I'm going to set this to is trigger. In a previous video, I wrote a script called item which creates an interface where we pick up our items, so we have to make a collect. You can do this or you don't have to. It's up to you. But back on our health item, I'm going to add a new component and a new script called health item. Then double click on this to open it up. So after mono behavior, I'm going to go comma item, and this has a red underline and asks us to implement our collect function. So now we have collect, and delete this middle bit. We won't need start and update. When we pick this up, we're going to want to destroy our game object. So this actually looks like we're picking it up. Now when we pick this up, we want our player to heal. Back in Unity, on our player, we have a player health script, which we set up in a previous video. On here, we have a variable for current health. It makes sense to handle our player's healing inside our health script. So in here, under our on trigger, I'm going to go void heal, and in the parameters I'm going to go int amount. Then when we heal, we're going to want to get our current health, so we'll go current health plus equals amount. Since we don't want this current health to go over our max health, we're going to go if our current health is greater than our max health, we're going to set our current health be back to our max health. And then because we have a script handling the UI of our health, we're going to go health UI dot update hearts current health. Now we need to know when we pick up an item and trigger this to heal our player. So back in health item, we're going to go public static event with a lowercase e, action with an uppercase A, and call this on health collect. Hover over action and we need using system, and then in collect, before we destroy this game object, we're going to go on health collect dot invoke. Now we copy this and go back to player health. In the start, you can see we're already subscribing to on reset from our game controller. We can subscribe to our new event in health item, so go health item dot on health collect plus equals heal. Now because we need to pass in our amount, this has got a little red underline, so back in health item we need to make our event actually pass in an amount as well. So to do this, on our action here, we can go less than int greater than, and in our invoke we're going to need to pass in the value of our health amount. So we can go at the top public int heal amount equals, and I'll just set this to 1, and then we can take our heal amount and pass it into our invoke. So now when we collect our item, we're going to invoke on health collect, and we're going to pass in our healing amount, then we're going to destroy our object. Then in player health, because we've subscribed to this event, when it goes off, we're going to call heal, get that amount that we've passed in, and add it to our current health. Very cool. Events are fun. So back in Unity, if I just drag this little health item and press play, we'll let our enemy hit us. Oh, I've lost some health. Quick, get that health back. Oh, it's back. There you go, it works. Cool, now I'm going to want this health item dropping from our enemy. To do this is very simple because we've added our loot table in the previous video. We select our enemy, press the plus on our loot table in the enemy script. When we open this up, we can add in a health item prefab. Let's drag our health item from the hierarchy into our prefabs folder, click on our enemy, drag in our health item. Just going to drag this to the top and set this to like 100. So it's the first one it checks. And now when we press play, I'll let him hit me. Now I need to make sure I kill him before he kills me. Da-da-da-dun. There we go. So we've got 2 healths to pick up. We pick up 1, it goes up 1, we pick up another, we're 4 health again. Very cool. And that's it. By the end of this video, we're going to add dashing to our game, where our player speeds up and becomes invulnerable so we can dash through our enemies instead of getting hit like this. Very cool, let's check it out. So we're going to want our player to dash when we press a button. In this project, we're using Unity's input system. So if we go to our input action asset and double click on this, in actions, we can click the plus and add a new action, which we'll call dash. Click on no binding, then on path, I'm going to click listen, and I'm going to press Q, which could be our dash button. Then on dash, I'm going to click the plus again and click add binding. So we can add another option for dashing. On path and click listen, I'm going to do right mouse button. So you can right click to dash as well. You can use whatever you like here. Whatever you want it to be, just set it up in these bindings. Then click save asset. We'll close this off. Then we'll go to our player. And currently all our player movement is inside our player movement script. You can get the first version of this player movement script, which works with our Unity input system, for free on my Patreon. So I'll link that in the description if you haven't got it. Otherwise, we'll double click on this and we'll add dashing to this script. So underneath movement at the top, I'm going to add a new header and call it dashing. Then we'll add in the variables we need. We're going to want a public float called dash speed and set this to a default of 20. A public float for dash duration. I'm going to set this to a default of 0.1, and then another public float called dash cooldown, and I'll set this to a default of 0.1 as well. Then we'll add our private variables. So we'll say bool is dashing and bool can dash. And we'll set this to a default of true. If you don't set a default for a bool, it'll default to false. And then for later, for our dashing to look cool, I'm going to add a trail renderer and just name this trail renderer. So we're going to have a little dashy line appear behind us when we dash. Cool, so that's all our variables. If we scroll down, just under move, I'm actually going to copy move and paste it here, and then replace the word move with dash, just because we want to use this same callback context. And then instead of this horizontal movement, we want to say if context dot performed, which means we've pressed our dash button all the way down, and we can dash. So our dash isn't on cooldown. Then we're going to start a coroutine, and in here we're going to pass in our dash coroutine, which we're about to write. So below this, let's go private I enumerator. This will come up with a red underline, so if you click show potential fixes and use system collections, and then we'll call this dash coroutine. Cool, so when we start dashing, we want to set can dash to equal false, because we're currently dashing, and of course is dashing to equal true. We'll use this is dashing now so you know what it's doing and why we have 2 balls here. So can dash is used for if we can call dash again, and is dashing is going to be used up into our update and say if is dashing, we want to return. This is so that as we're dashing, we can't change direction, but we do want our animations to work. So I'm just going to cut these animators down here where we're setting our parameters and paste it just above is dashing. So our animations will be set, but while dashing, we'll not be able to do any other inputs. Cool, back to our dash coroutine. For our fancy trail emitting, I'm going to go trail renderer dot emitting equals true. Now we haven't seen what this does yet, but this is basically going to turn our trail renderer on, and we're going to set this up later. If you don't want a little line popping out of your character, you can just leave this bit out. Then we need to figure out our dash direction. So I'm going to go float dash direction, and it's going to equal our is facing right boolean that we've been using when flipping our character and wall jumping. Then we'll go question mark 1f colon minus 1f. Well, basically what this is saying is if we are facing right, we'll set our dash direction to 1, else if not, we'll set it to -1. And we'll use this below with our rb.velocity and set this to equal a new vector2. And in here we'll pass our dash direction. We'll times this by our dash speed. So that's our x velocity. Then we'll set our y velocity to be rb y velocity y, so we won't change it. So this is our dash movement. Now we want this dash to last for a specific amount of time. So we're going to go yield return new, wait for seconds, we're going to pass in our dash duration. So once this ends, we'll return to our normal speed. To do this, we'll go rb.velocity equals new vector2, we'll pass in 0f, then rb.velocity.y. Cool, so that resets our horizontal velocity. So now we'll set is dashing to be false, and our trail renderers emitting to also be false. We'll group these together above so it looks nice and tidy. Cool, now we want to reset our cooldown for our can dash, so we can dash again after a certain amount of time. So we're going to go yield return new wait for seconds and pass in our dash cooldown. When this is finished, we'll set can dash to true. Cool, and before I forget, for our trail renderer to work, we need to grab the component off of our player. So up the top, let's add a start function, and we'll just go trail renderer equals get component trail renderer. Cool, and that should be it so far for adding some basic dashing to our player. So let's go back to Unity. Now if we select on our player and open up player input, then open up events, then open up player, we'll scroll down and we can see we've got this dash event here. We click the plus, then drag player into this object slot. On this no function drop down, we'll go to player movement and then dash. So now our dash is set up, we can now add our trail renderer. So let's close our player input, go add component, trail renderer, and there's lots of different options you can play with in here, but I'm just going to show you the way I set it up for my dash. So my width, I want it to be 0.3. My time, I make it 0.1. I turn emitting off by default in this little tick box, and then if you select color and then select the top right of these little tags, I turn the alpha down to 0. So it's kind of like a faded away tail. And then last thing to do is under materials, we'll open this up, click on none material, and we'll select sprites default. Cool, so now if we press play, I can now dash to the side. Because my cooldown is quite low, I can dash quite frequently. But you can add a higher dash duration if you like. So in a lot of games, you can dash through enemies and go invulnerable. And that's the kind of thing I want to add to our game. Otherwise, I just keep running into our enemies and getting hurt. So our player gets hit when colliding with our enemies. One way of making our player invulnerable to enemies is using Unity's Physics 2D Ignore Layer Collision, where we pass in the IDs of the layers that we want to be ignored. So in Unity, on our player, I'm going to add a layer and make this the player layer. Then I'm going to add another layer and name this one enemy. Now on our player, I'm going to go to layer, select player, then in our prefabs, I'm going to select our enemy and go to layer and select enemy. If I go to edit and project settings and to the physics 2D tab, you can see I've got this matrix of different tick boxes saying which layers collide with which. What we're going to do in code is basically untick this enemy to player one whenever we dash and then tick it back on when we're done. So let's do that. Back in the code, at the very top, when we begin dashing, I'm going to go physics 2D ignore layer collision, and we can pass in the numbers that we used for our layers. So for me, it was number 7 for our player and number 8 for our enemy. I'll show you again in a moment. And then in our fur parameter, we want it to be a boolean of whether we want to ignore this layer or not. So yes, true. Then at the bottom, when we're no longer dashing, but before our dash cooldown yield, we're going to do the same thing, but say false. We do not want to ignore this layer. And that's all you need. We now go back to Unity. You can check quickly which layer you need. If you click on any layer drop down, you can see 7 is player, 8 is enemy for me. This may be different for you. So just double check. But if we press play, now when I stand next to an enemy and dash, I don't get hit. Oh, I did because I finished dashing. So my dash is quite short. You can change your dash duration on your player under your player movement script. Set it to something a bit longer, like 0.5. But you see our character now goes flying across the screen and is invulnerable. So that's obviously a bit much. You can find the balance for your game, depending on what kind of thing you're doing. But yeah, that's dashing. By the end of this video, we're going to be able to drop down for our platforms and also be able to jump back through if you've done the previous video. If you haven't seen the video about how to go up through the platform, you can check that one out. It's really short, so won't take up a bunch of your time. This one's just for dropping back down through the platform. Very cool, let's get started. If you haven't been following the series so far, you can skip ahead to this time. But if you have, well, how we've currently got our project set up is with this ground tile being for our bottom floor and for our platforms. If we want to drop down for these platforms now, we're going to drop for our bottom floor, which we don't want. So in our tile palette, I'm going to have the active tile map as ground. I'm going to select this eraser. I'm going to erase the bottom floor down here. Then what I'm going to do is copy ground and paste it. I'm going to rename this bottom floor. Back to our tile palette with the eraser selected still, an active tile map now switched to bottom floor. I'm going to erase these platforms. So just go over them, you'll see your collider lines are disappearing. I've got some at the top as well. And then what I'm going to do is select this little tile down the bottom for our flat line and draw our bottom floor on. You can see we've got our platform effector 2D still showing. You can go to your composite collider 2D, untick unused by effector, and then we'll remove this platform effector 2D from our bottom floor. Now make sure you do this for level 2 as well and any other levels you have. Cool, okay. So in this project we're using Unity input system. So I'm going to open up my player controls from my assets and add a new action. I'm going to call this drop. And on no binding, I'm going to select this, select path and click listen. I'm going to press S on my keyboard so we can drop down using S. I'm going to add another binding. So you go to drop the plus, no binding, and click listen again. I'm going to press down on my arrow key. So you can press down arrow or S on your keyboard. And then we'll drop down our platform. Click save asset and close this off. And we'll click on our player and go to player movement. Double click on the player movement script. So in player movement, if we scroll down just above our jump, I'm going to go public void drop. Then we'll pass in input action dot callback context, call it context. And in here we're going to check if our context has been performed, so if we pressed our drop button, and is grounded, and then we're also going to want to know if we're on a platform, because we may be grounded and on that bottom floor. So we'll say and is on platform. When this is true, we're going to call a coroutine for dropping. Cool, so let's go up the top and make this is on platform. We can go under our ground check, so we'll go bool is on platform. Cool, and we can scroll back down, and to know if we're on a platform, we're going to go on collision enter 2D, and we'll say if our collision.game object.compare tag is platform, then is on platform equals true. And we're going to want a on collision exit 2D, and we can copy what was above in the enter and set is on platform to false. Cool, now we have our is on platform boolean set up. We can now write a coroutine for dropping down. To drop down, I'm going to keep it simple and disable our player's collider. My player has a box collider, which keeps me standing up. I'm going to go private I enumerator and call this disable player collider. I'm going to pass in a float of disable time. Now we're going to want to grab our player's collider and set it to false here so that we're not grabbing it over and over again. Let's scroll to the top and we'll go box collider 2D, player collider, grab this, and in our start where we're getting our trail renderer, we're going to go player collider equals get component box collider 2D. So now we have our player collider. Down in our disable player collider, I'm going to go player collider dot enabled equals false. By disabling our collider, we're going to fall through our platform. We only want this to be disabled for a little bit. So I'm going to go yield, return, new wait for seconds, and I'm going to pass in our disable time. And underneath, I'll copy this line and go player collider enabled equals true. So our player will be landing on our platforms again. Now all we have to do is in our drop function above, go start coroutine and pass in disable player collider, then pass in our disable time. So I'm going to go 0.25f, which should be enough time for us to drop through before touching any of our other platforms. And so this doesn't keep getting called over and over while we hold down S and we start a million coroutines. In our drop check, we're going to go and player collider dot enabled. This lets us know that we're not currently dropping, and that should be it. Back in Unity, and whatever you have that is holding your platforms, for me that's my ground Tilemap, click on your platform's object and under your tag, go add tag, click the plus, add platform, click on your object again that has the platforms and select platform in this tag. Remember, if you've done this the same way as me, you're going to need to go and change ground in level 2 as well, unless if you're using a prefab, then that's fine. Cool, and finally, if we go to our player, go to player input events player and scroll down, we can see our move event, jump event, hold event, and now we've got our drop event down here. If we click the plus and then drag player into this slot, under no function, go to player movement and then pick drop. And now when we press play, so now I can press S and drop down, and I can't drop through our final bottom floor, and I can jump up and go back through. So cool! By the end of this video, we're going to have a moving platform. We're going to set up waypoints that you can customize to be however you like. So not just horizontal, but could go vertical too, or maybe diagonal. We'll also make it so either your player sticks to the platform or will slide away and get left behind. Cool, let's take a look. In our series, I've been using Kenny Games tile palette. In his tile palette, he's got this cool conveyor belt looking platform. I pulled this sprite out of the tile palette and made it its own sprite so we can use it for our moving platform. If you want this, you can check it out on my Patreon for free. So I'll link that below. So if you do want to use that, I'm just going to quickly set this up after dragging it into Unity. I'm going to set the pixels per unit to be 16, filter mode to be point no filter, and compression to be none. Click apply. Now we can get started. Let's right click in our hierarchy, create empty, go moving platform. This is going to be the parent object for all our little grouped platform business. Now if you right click on moving platform, go 2D object sprite square and call this platform. Then I'm going to drag my platform image into the sprite renderer. Now if we right click on moving platform again and go create empty, and I'm going to call this point A, and then right click again, create empty, and call it point B. If you click on point A and look in the inspector, you can see this cube at the top with a drop down. If you click on that and select a symbol, I'm going to click the red diamond and move it to the left. And then point B, I'm going to select a blue diamond and drag it to the right. These are going to be the waypoints that our moving platform bounces between. So it's going to go over to the red. Once it's there, it's going to move back over to the right, to the blue. Keep this tidy. I'm going to set point B position X to be free and point A position X to be -3. You can make these positions any way you want, so they can go up above and it'll move diagonally between these two. It can go up and down, so you can have that one at the bottom and point B at the top, whatever you fancy. I'm just going to do it side to side for now, but whatever you want your platform to do, this script will work. So if we set up our platform now and go add component, box collider 2D, and then we'll add another component and do platform effector 2D. If you click use by effector on your box collider 2D now, This will mean that you can jump from below and to up above the platform and land on top. If you also want to be able to drop down from the top and you followed our previous episode where we implemented this, remember to click tag in the drop down and then select platform, and you'll be able to drop down on this platform just like any other. Cool, so now let's add a new script and call it moving platform. We'll double click on this to open it up. So at the top, let's add our variables and go public transform point A, and then public transform point B. Then we'll go public float move speed, and I'll set this to a default of 2. Now we'll want a private vector free, and we'll name this next position. In the start, let's set our default next position to be point B dot position. Then in our update, we'll set our transform dot position to equal vector free dot move towards, and we'll pass in our current position, which is transform dot position, our target position, which is our next position, and then our speed, which is move speed times time dot delta time. Cool. Now we want to check if we've reached our destination. So we'll say, is our transform dot position equal to our next position? And if it is, we want to set our next position to equal either point A or point B, depending on which one we haven't reached. So let's get some brackets in here and go, is our next position equal to point A dot position? And add a question mark because we're asking it a question. So yes, our next position is equal to point A. So let's set it to point B dot position. Else, if it wasn't, we'll set it to point A dot position. This is basically a shortened if statement, and it'll get us bouncing between point A and point B. And that's everything you need to get your platform moving. So let's go back to Unity, and on platform, let's drag in point A into the point A slot and point B into the point B slot, and click play. Now you can see our platforms moving left to right. Now, if you take a look, when I jump on board, you can see it's moving under my feet. This might be how you want your platform to go, but if you don't want your player falling off and it moving without you, and instead sticking your player on for the ride, then what we can do is set our player to be a child of our platform. But of course, we're going to do that in code instead of in our hierarchy. So if you just did that, undo it. And then back in our code, on our moving platform script, we're going to say on collision enter 2D, if our collision.gameObject.compare tag is player, then we're going to set our collision.gameObject.transform.parent to be our transform. Now we want one for on collision exit 2D. So we'll go on collision exit 2D. We can copy this same code from above, checking to make sure it's just our player that we're doing, and we'll set our parent to be null instead of transform. Cool, and that should be it. If we go back to Unity, just click on your player and make sure your tag is player, then press play. Now when we jump on our platform, we stick to it. You can stand anywhere on the platform. It just means you'll be coming with. And then you can also jump off your platform and go away. Now, if you followed this tutorial series, you may see that once you've joined this platform, you can't jump anymore. That's because we haven't set our platform to be on the ground layer. So if we click on platform and in the layer drop down at the top, select ground. Now, when we press play and we get on our platform, we can now jump on our platform. Very cool. That's everything. Just so you can see, we can move these points anywhere. So I'll move them up and down very messily. And you can see it's moving up and down just like it was left and right. And our enemy enjoys it as well. You can also make it go diagonal, which is pretty cool, or just do whatever you want. If you wanted to add more waypoints, just an idea on how to do that, like going around in a circle or something, you can instead put your points into an array on your script and iterate around it, making them the next position. I know you're smart enough to figure that out, so I won't show you how, unless you want to, and it'll be a very short video. But what I will show you in the next video is falling platforms. By the end of this video, we're going to add falling platforms to our game, which will fall after a set wait timer and then be destroyed. Very cool, let's go. So in our series, we're using the Kenny Game tile map, and like I did for our moving platform, I took some sprites from this tile map and made it into an individual image. I've dragged this into my Unity project and set the pixels per unit to be 16, filter mode to be point no filter, and compression to be none, and clicked apply. And if you want to use this as well, you can grab it for free on my Patreon, which I'll link below. But anyway, first of all, let's right click in the hierarchy and go 2D object sprite square and call this falling platform. I drag in my platform sprite and I'm going to click add component and add a box collider 2D and add component again and add a platform effector 2D. If you click use by effector in your box collider 2D, this will now make it so your player can jump from the bottom up and land on our platform. If you want to also be able to jump down, and you followed in a previous video how to do this, remember to select the tag platform in this drop down at the top. And for our ground check, if you've done this series as well, remember to select ground on our layer drop down. Cool, now on our box collider 2D, I'm going to edit the collider and wrap it around the very very top of our platform in a tiny little rectangle. So when we collide with here, the platform's going to start falling. Because we want our platform to fall, it means that our platform needs to have gravity. So let's add a component and add a rigid body 2D. Since we don't want our platform to fall from the very beginning, what we're going to do is set its body type to be static. This means it will stay where it is. When we want this then to fall in code, we're going to set it back to dynamic, which will make it fall down. Speaking of code, let's add component and click new script and call it falling platform. We'll double click on this script to open it up, and in here we'll add a public float fall weight, and I'll set this to a default of 2. So this is going to be when our player jumps on the platform, going to stop and wait for 2 seconds and then start falling. And we'll want another public float and we'll call it destroy weight. I'm going to set this to 1F so that after 1 second and after falling, our platform is destroyed. Now let's add a ball called is falling and a rigid body 2D for our rigid body 2D, which we'll call RB. In our start, let's set our rigid body 2D by calling get component and passing in rigid body 2D. And then we won't need this update method, but we will want an on collision enter 2D where we're going to say if we're not currently falling and our collision .gameObject.compare tag is player, and we'll pass in player. So is our player colliding with our platform? Then we're going to call a coroutine, and I'm going to call this fall. So let's write this fall. Down here we'll go private I enumerator fall, and we'll say is falling equals true. Then we're going to yield return new wait for seconds and pass in our fall wait. So we've jumped on our platform, we said yes we're falling so this doesn't get called again. And now we're going to wait for 2 seconds. After we finished waiting, we're going to set our rigid body's body type to equal rigid body type 2D dynamic. So our platform will start falling. Then we want to call destroy. We'll pass in our game object, so that's our platform, and then pass in the time to wait, which is destroy wait. So after 1 second, our platform will be destroyed. So it's not just falling forever. And guess what? That's it. So let's go back to Unity, and I'll move this platform somewhere that's not going to crush our person. Now when we jump on top of our platform, we wait and it falls. Oh, we didn't freeze the Z rotation, so it looked a little weird. So if we go back, click on falling platform, and on our rigid body, if you click on dynamic, we can change the constraints here and they'll save for when it switches back between static and dynamic. So I'm going to click under constraints, freeze Z rotation, and then I'll set this back to static again. Press play. And cool, now when we jump on our platform, we'll wait 2 seconds and it falls down nice and smooth. Cool. And that's it. Very cool. Now you can try and avoid the falling platforms. Very exciting. You can up the fall time so it falls a little faster once you've stepped on it. If you go to all your platforms and set the fall weight to be something shorter like 0.5, and if we test it again, you can see they fall after half a second, which makes it a little more challenging. By the end of this video, we'll have added a bounce trap and a spike trap to our game. When you hit the spike trap, you'll bounce up in the air and take damage, and when you hit the bounce trap, you'll bounce up in the air, but you won't take damage. Very cool, let's check it out. So let's start with our spike trap. We'll right click in our hierarchy and go create empty and call it spike trap. Then click add component and add a sprite renderer. And in the sprite renderer, I'm going to select the spike sprite from Kenny's Tilemap. I'm going to click the move tool in our scene view and drag this down so it's just above this platform. Next, let's add another component and add a box collider 2D. And I'm going to click is trigger. Then I'm going to edit the collider and zoom in here and just make this fit to the top of our spike and then pull it in from the bottom up a bit and to the sides, so we get hit when we touch the very tip of the spikes. Cool, now we'll write the script for our trap. So if we click add component, new script, and we'll call this trap, and we're going to name this trap instead of spike trap because we're going to reuse this for both spike and bounce trap. If we double click on this to open it up, and in here I'm going to add a public float called bounce force and set this to a default of 10F. Then I'm going to do a public int called damage and set this to a default of 1. We're not going to need start or update, but we are going to want to write a on trigger enter 2D function. And in here we'll say if our collision.gameObject.compare tag is equal to player, so then we pass in player, then we're going to call a function called handle player bounce. And in here we're going to pass our collision.gameObject. So let's write this function. Down below we'll go private void handle player bounce, and the parameter will be a game object called player. To get our player to bounce up, we're going to want to get the rigid body 2D. So I'll have a rigid body 2D called RB, and we'll do this equals our player.getComponent rigid body 2D. Now we're going to check if this was successful, and we did get a rigid body by saying if RB This checks if it's null or not. So if it's not null, what we're first going to do is reset our player's velocity in case we're already applying any gravity effects. So we'll go rb.velocity equals new vector2, and we're going to pass in our current rb velocity.x, and then on the y we're just going to simply pass in 0. So now our player's y velocity is reset. We can apply our bounce force, and to do this we can go rb.addForce. Because we want us to bounce up, we'll go vector2.up times by our bounce force, and we'll go comma force mode 2d.impulse. This uses the rigid body's mass to apply force in case your mass is higher. Cool, so with this script, when we press play and we hit one of our traps, we bounce in the air, but you can see we're not taking any damage. Our damage is currently handled in our player health script. So to keep it consistent, we'll handle this in here. So if you click on our player and go to player health, we can see we have an onTriggerEnter2D function where we're checking if we collide with an enemy, we'll take damage, depending on the enemy's damage amount. Below this, we can do the same thing for a trap. So if we get the trap object and go equals collision.getComponent trap. So we're trying to grab the trap script off of whatever we've collided with. And we'll say if we do collide with a trap, then we'll take damage and pass in our trap.damage. And we'll also only want to do this up in our if our trap.damage is greater than 0, because spoiler alert, our bounce trap isn't going to do any damage. And we don't want to keep calling this function if not necessary. Cool, so now if we test this out in Unity, when we press play, now when we jump onto a spike trap, we bounce up in the air and take damage. Now to make a bounce trap, if we select our spike trap, copy by pressing Ctrl+C, and then pasting by pressing Ctrl+V, I'll rename this one bounce trap, and I'll set the damage on our script to 0 and our bounce force to 15. Then in the sprite renderer, I'm going to select a different sprite, and we'll use the one of this bounce trap. I'll move this over in our scene, and then check our box collider 2D. You can see this isn't on the top of our bounce trap. I'll just drag this to the top and just make sure it fits. Cool, now with damage at 0 and the bounce force up, we can use this to spring up. So if we press play, we can now jump on our bounce trap and spring into the air. And that's it, a fun and easy way to add traps to your game. By the end of this video, we'll have added hidden areas to our game, which will fade in when you enter them and fade out when you exit. These can be fun for hiding secret items, enemies or traps. So cool, let's check it out. First of all, I've added this new tile map called Decor, which I have things like signs on. These will have no collision and are just for decoration. I'm gonna put something on this platform over here for us to hide. So some flowers and some plants. To make this symmetrical, what I wanna do is flip this sprite. Just a handy little tip, if you hold down Shift and then press the left square bracket, it'll flip your sprite horizontally. If you hold Shift and press the right bracket, it'll flip it vertically. But cool, now we got some little flowers that I'm going to hide behind a secret area. And just to make it more interesting, I'll hide a health item as well. Cool, so now we go to our hierarchy, right click and go 2D object sprites square. Then what I'm going to do is drag the square over to where we want to hide our items. You can click this rect tool in the scene view, which gives you these little options to drag out your shape. To make sure this is always in front of your items, what you can do is select your furthest away sorting layer, mine's player, and then in the order in layer, if you just type 1 or any higher number, it'll push this to the front of the layers. Or you could just add one more layer called hidden area, but I'll do it the easy way. Now what I'm going to do is change the color and use the eyedropper and select our background color. Or you could replace this sprite renderer sprite with whatever your background is, in case you have a pattern or something. Next I'm going to click add component and add a box collider 2D, and then I'm going to click is trigger. Now I'm going to click add component again, go to new script and call this secret area. I'll double click on this to open it up, and in here we'll add a public float called fade duration. I'll set this to a default of 1. Then I'm going to want a sprite renderer. I'll call this sprite renderer. A color, which I'm going to call hidden color. And we're also going to want a reference to a coroutine to store our current coroutine. Cool, now in start, we're going to go sprite renderer equals get component sprite renderer, and then hidden color is going to equal sprite renderer dot color. Not going to want this update, so we can delete that, but we are going to want an onTriggerEnter2D, and we're going to want to check if our collision dot game object dot compare tag is equal to player. Then we'll check if our current coroutine is not equal to null. We're going to call stop coroutine and pass in our current coroutine. So if our player has walked in, we're going to set current coroutine to equal start coroutine, and we'll call a function that we haven't read it yet called fade sprite. So let's write fade sprite. We'll go private I enumerator fade sprite, and in the parameters we're going to pass in a bool called fade out. So we want it to turn transparent if this is true. We're going to want a color called start color, and we're going to set this equal to sprite renderer dot color. Then we'll want a color of our target color, and if we are fading out, we're going to want it to be transparent. So we need to make a new color and make it a transparent color. So that'll be hidden color.r, hidden color.g, and hidden color.b. And for the last parameter will be the alpha. which we're setting to 0. The alpha is the transparency. Then we'll go colon, so if we're not fading out, we want to fade in, we'll set it back to our hidden color. And we're going to need another little float here, and we'll just call this time fading. Then we'll say while time fading is less than fade duration. Oh, and we'll set time fading to 0f. Then inside our while, we'll go sprite renderer dot color equals color dot lerp, which you can see interlopes between colors A and B by T, which basically means it's going to change from one color to another over this amount of time. So we're going to go start color, target color, time fading divided by fade duration. And under this we'll go time fading plus equals time dot delta time, then call yield return null. And at the very end we'll go sprite renderer dot color equals target color. Then up in on trigger enter 2D in our fade sprite, when we enter we do want it to fade out, so we'll set this to be true. And under this we'll write another on trigger exit 2D, copy what's from the trigger enter, and in fade sprite we'll instead say false. Cool. So now if we go back to Unity and press play, we can go over to our little secret hidden area. You can see it fades in and fades out. The only thing is, I don't know if you can tell, but it seems to stutter and not fade smoothly. There, you just saw it. Oh, it's kind of freaking out when I enter and leave very quickly. This is because both coroutines are being called at the same time. As we enter and leave, we keep calling different coroutines. So if we go back to the script, an enemy, get him! If we go back to the script, and in our onTrigger enter 2D, inside our if, when we know it's our player, we want to say if our current coroutine does not equal null, we want to call stop coroutine and pass in our current coroutine. Then copy this code and do the same thing in our onTrigger exit 2D. And that's all you need. Back to Unity. Now when we enter our hidden area, you can see it fades in and fades out, and if we do leave, it'll stop and start the other coroutine as needed. That's a lot of enemies, oh my god. This just makes things a bit smoother. So as soon as you leave, it'll start fading out, and as soon as you enter, it'll start fading back in. Cool, I didn't actually rename this hidden area, so I'm going to do that now. I'm going to drag this into my prefabs folder to make this a prefab, and I'll show you some fun things you can do. So we can of course drag multiple of these onto our scene. When we press play, you can make this hidden area any size you want. Just edit the size of your sprite and the box collider around it. Oh my god, hidden enemy. And yeah, you can make some cool fun stuff. Something else you could hide behind these hidden areas could maybe be like a power-up item, like we're gonna make in our next episode. By the end of this video, we're gonna add a speed boost item to this game. So when you pick it up, you'll have a cool trailing effect and you'll be faster. A particle effect will flip and change with our character, as well as look really cool. Cool, let's check it out. So first off, in the hierarchy, let's right click and go 2D object, sprites, square, and I'm going to call this speed item. In the sprite renderer, I'm going to go and select this exclamation mark icon from the Kenny Games 1-bit tile map. I'm going to make the scale 0.5 by 0.5. I'm going to change the color to be purple. It stands out more. Then I'm going to click add component and add a box collider 2D and click is trigger. Next I'll click add component and go new script. And we'll add a new script called speed item. If we double click on this to open it up, then we can delete our start and update, and at the very top, next to mono behavior, I'm going to go comma I item. We added this I item interface before, which basically just made it so we added a collect function. So I'm going to delete the middle here, and at the top, I'm going to go public float multiplier. This is going to be our speed multiplier. In fact, I could call it speed multiplier to make that clearer. And I'm going to set this to a default of 1.5f. So when we collect this item, whatever script handles our player movement, we're going to want to let it know that we've picked up a speed boost. To do this, at the top we're going to write a public static event action with a capital A, and inside triangle brackets we'll pass in a float, which is going to be our speed multiplier, and I'm going to call this on speed collected. If you hover over action, we'll be using system, and now in our collect we can call on speed collected dot invoke. Our invoke is asking for a float, so let's pass in our speed multiplier. And because we've picked up this item, we then want to call destroy game object. Cool, and that's all we need in here. So if we go back to Unity, if we select our player, you can see we have this player movement script. You can use wherever you handle your player movement, but we'll double click and open up this script. And as you can see at the top, we've got a move speed variable. What we're also going to want underneath here is a float for our speed multiplier. We'll set this to a default of 1f. So of course that shouldn't change our movement speed because we're timesing it by 1. Now let's move down and find where we use our move speed. If you highlight this and press Ctrl F, it'll bring up the find and it'll show you a highlighted move speed for us. So this is where we do our movement. Here where we're timesing horizontal movement by our move speed, we also want to times it by a speed multiplier. And finally in our start, we're going to need to subscribe to our speed item dots on speed collected. And we're going to have to write a new function here for this to subscribe to and call whenever we pick up our item. I'm going to write this just below the start so we can see it all together. And I'm going to go void speed boost. And we're going to want this to take in a float of our multiplier. Now, because we want this to be a temporary speed boost and go back to normal after a certain amount of time, we're going to want to use a coroutine. Let's rename this to start speed boost. And we can copy this and paste this up above to be what our item calls when it's picked up. So now start speed boost is going to need a coroutine to call. So let's go private I enumerator speed boost coroutine. This will also want a parameter of float multiplier. Cool, so in here, nice and easy, we're going to want to set our speed multiplier to be the new multiplier passed in. We're going to want to yield, return, new, wait for seconds. Let's wait 2 seconds. And after 2 seconds, let's set our speed multiplier back to 1. Now in our start speed boost, we can go start coroutine, pass in speed boost coroutine, and in here, pass in our multiplier. Cool, and that's it. Let's go back to Unity. I'm going to move my speed item down to the side. Now on our speed item, you can see our speed multiplier is set to a default of 1.5. So this should increase our speed by half on top of what we already have. I'm going to set this to something really high just so you can see it like free. Press play. When we pick up our item, this is how fast we're currently running. Oh my god, enemies, quick! Get the item! Whoa! Okay, that's very fast. And then after 2 seconds, we go back to normal. To make this easier to visualize and make it a little bit cooler, like we did for turning and jumping, we added particle effects. So let's add a particle effect for our speed boost. On our player, if you open up, we can see we've got this smoke FX, which we're currently using for jumping and changing direction. Check out that video if you're interested. So let's make a new one for our speed boost. I'm going to right click on our player and go effects, particle system. I'm going to rename this speed FX. The duration we won't care about too much. I'm going to set it to 0 because we do want this to be looping this time. Our start lifetime will be 0.5 and our start speed is going to be 1. And I'm going to make our start color half transparent, around 150. The simulation space is going to be world. And I'm going to set max particles to be 5 and play on awake is going to be false. That's it for the top bit. Emission we can leave as it is. And the shape I'm going to set to sprite and then the scale to be 0, 0, 0. Then I'm going to tick on velocity over lifetime and I'm going to set linear x to be minus 0.1. and linear y to be minus 0.1, and we'll change the space to be world. What this will do is as we move, it'll fly off behind us. Next, color over lifetime I'm going to tick on. Click on this, and then at the top right tag, set the alpha to be 0, so our sprite will fade away over time. Then texture sprite sheet animation, tick this on, set the mode to be sprites, and then here we select a sprite. So from our Tilemap, I'm going to select the image of our character walking. Then finally in renderer, on order in layer, I'm just going to set this to -1 just to make sure it goes behind our player. And in renderer as well, on your material, you're going to want to pick sprites default. And that should be it. If we turn on play on awake and press play, we can see we now have this cool effect where it looks like our player is going so fast that it's got like a stream of ghosts behind it. Let's remember that this sprite isn't flipping. We can fix that when we add the code in to get this effect to play. So let's now go to our code, remember to turn off play on awake, and we'll go back to our player movement script. At the very top, you can see we've got a public particle system for smoke effects. If we duplicate this by pressing Ctrl D and add in a speed FX, then we'll scroll back down to where we're doing our speed boost routine. On here, all we have to do is go speed effects dot play before our yield wait, and after our yield wait, we'll go speed effects dot stop. Now to get this to flip with our player, all you have to do is go to where we flip our player when we change directions. So if you see in our update, we have this function called flip. If I hold down Control and click, we can see we're passing in this local scale to our transformed local scale of our player. This is making our player's sprite flip. If you duplicate this code, and then just before transform, you can type speedfx dot. So we've got speedfx dot transform dot local scale equals our new local scale. This will make our particle sprite flip with our player. So cool, if we save this, go back to Unity, and in our player movement script, don't forget to drag your speedfx object into your speedfx slot inside player movement. And I'm also going to go to our speed item and set this back to 1.5. So we're not going crazy fast anymore. Cool, so now when we press play and we grab our speed boost item, you can see we got our cool flipping sprites. It actually changes direction when you move, and we get a nice little speed boost. You can do this with any other kind of boosting items using the same kind of idea, like a damage modifier, size modifier, anything like that. You can use a similar concept. So yeah, hopefully that gives you some ideas. By the end of this video, we're going to be adding sound effects to our game, like this, or this, or this, or whatever you want. and also adding in a volume slider. Cool, let's check it out. So first off, the plan is we're going to have a library script and a manager script. In our library, we'll be able to store lists for our sounds. So these examples, I'm going to add in a player hit sound effect, gem sound effect, and bounce sound effect. Then our manager is going to be able to grab from our pool of many sound effects in our library and get a random sound. So each time we do an action, it doesn't sound the same and get repetitive. And we're also going to add a slider to be able to set our volume. So in our hierarchy, let's create a new object and we'll name this sound effect manager. Because this is dealing with audio, we're going to want to click Add Component and add a audio source. Then we'll click Add Component again, go New Script, and first of all, let's add our sound effect library. In our library, I'm going to add a private dictionary. And for our key, we're going to have a string, and the value is going to be a list of audio clips. I'm going to call this our sound dictionary. A dictionary is the most efficient way of storing things that you want to be able to grab with a certain key. In our library, we're going to use a string as our key and make this match the name of what we want our sound effects to be. For example, gem, player hit, or bounce. Now, dictionaries are very good, but they can't be accessed in Unity's inspector. So what we're going to do is make a new class that can be viewed in the inspector and use this to populate our dictionary. So we're going to go public struct sound effect group. In here, we're going to place our public string name, which is going to be the key for our dictionary, and then a public list of audio clips called audio clips. Now above sound effect group, type some square brackets and then go system.serializable. This makes it so we can view it in the inspector. So now back at the top, we're going to go square brackets, serialize field, private, sound effect group, square brackets again to make this an array, and call this sound effect groups. So if I jump back to Unity, you can see we have these sound effect groups that if I open, I can add a new element where we can add a name and our list of audio clips. We'll populate these later. For now, back in our script, we're going to want to use the awake function and use this to initialize our dictionary. I haven't written this function yet, but if you hover over and click show potential fixes, you can just click generate method and it'll add in this method for us. So to initialize our dictionary, we want to go sound dictionary equals new dictionary of string and then list of audio clips. And then we'll go for each sound effect group in our sound effect groups. We want to say sound dictionary, square brackets, sound effect group, and we want the name to use as our key, and then we'll set this to equal our sound effect group dot audio clips. So we grab the list of audio clips and stick it in our dictionary under the key of our name. And we don't want this start or update, so we can delete those. Then we're going to want a public audio clip get random clip. And inside the parameters, we're going to pass string name. First, we need to check if it exists in our library. So let's say if sound dictionary dot contains key name, then we're going to go list audio clip and grab our audio clips from our sound dictionary and go set square brackets and pass in the name. So now we want to check and make sure if our audio clips dot count is greater than 0, then we're going to return an audio clip with the index being random dot range and passing in 0, comma, our audio clips dot count. So even if you only have one audio clip in this list, this will still work, as well as having 50 audio clips for it to choose from. Random has a red squiggle underneath it, so just go show potential fixes and use unityengine.random. Now we need to return something from all our paths. So at the end, if this has not returned and we don't have any audio clips, you can return null outside of here. Cool, now that's all done, let's go back to Unity, and on our sound effect manager, under sound effect library, let's open up sound effect groups, and you can see we've got this list is empty. So I'm going to click the plus and add 3 different elements here, since I've got 3 different groups of sound effects I want to add in. The first one is going to be our gem sound effects, so when we pick up a gem. And for my sound effects, I'm using Kenny Games assets again. It's got lots of free sound effects on here, but I'm using these sci-fi sounds. So in my assets, I'm going to right click and go create folder, call this sound. Inside here, I'm going to create another folder and call this gem. And then go inside this. And for our gems, I'm going to use power up 2, 7, 8, and 9 and drag these into our folder. If you notice on this file type, you can see it's type OGG or OGG. This is the file type commonly used with sound effects. Now on our sound effect manager, a little tip so we can keep this sound effect manager open while selecting our sounds is right click in the inspector and clicking properties. This brings us a little pop out of our sound effect manager. So now I can select other items and still have my sound effect manager here for me to put stuff into. So I'm going to select all of my gems, sound effect clips, and then drag them over on top of audio clips. Now these are all inside. We're going to want to write our next script, which is our manager. It's going to have the functions for us to call to play these sound effects. So on our sound effect manager, let's go add component, new script, and call it sound effect manager. Double click on this to open it up, and to make this callable from any of our scripts, we're going to go private, static, sound effect manager, and create an instance of this script. To make sure we only have one of these instances at a time, we're going to go awake and say if instance equals null, instance equals this. And so this isn't destroyed if you change scenes or anything like that. We'll say don't destroy on load and pass in game object. We want to say else, if there is already an existing instance of this, destroy this game object. Cool. Next we're going to want a private audio source called audio source, a private sound effect library called sound effect library. And for changing the volume, we're going to get a serialized field, private slider, and I'll call this SFX slider. Hover over slider and add in using Unity UI. Now we need to get our audio source off of our game object. So in our awake, just below instance equals this, we'll go audio source equals get component audio source, which is going to grab the audio source off of this game object. And we'll do the same thing for sound effect library. So sound effect library equals get component sound effect library, which is going to grab our script for us that we just wrote and added to this sound effect manager. Cool. So first let's add a public static void play. And in the parameters, add a string called sound name. In here, we're going to pass in a name of the sound effect we want to play. Then we're going to want to go audio clip equals sound effect library dot get random clip. And we'll pass in our sound name. Oh, this has a red underline because both our audio source and sound effect library need to have static in the beginning. So just go up to the top and add these here. So now we've got our random audio clip from our library. We'll double check and say if our audio clip is not null, then we tell our audio source to play one shot, and we'll pass in our audio clip. Using play one shot is good for our sound effects, because as it says, it plays our sound effect once. Now we can write the code for adjusting our volume. So we can get rid of update and instead go public static void set volume and pass in a float of our volume. And all we do here is say audio source dot volume equals volume. Now we're going to want this to be called whenever our slider value is changed. So let's go public static void on value changed, and then call set volume and pass in our SFX slider dot value. Again, this needs to be static since our whole instance is a static one. And finally, to get this to actually be called whenever our value is changed in our slider, what we can do is say SFX slider dot on value changed dot add listener, and in the brackets we'll type delegate curly brackets, and inside the curly brackets go on value changed. Now we're going to want a semicolon after on value changed brackets, and then at the very end. And I made a mistake just now. This slider variable shouldn't be static, and this has a red underline because this function shouldn't be static. So sorry about that. Cool. So now if we go back to Unity, on our sound effect manager, when you scroll down, you can see we have a slot for our slider. I have a canvas set up already called UI, where I'm going to right click and go UI slider and call this my SFX volume slider. I'm just going to double the scale on this. If I double click on my UI in the hierarchy, you can see your canvas. Click on my SFX volume slider, click the move tool and drag it to my top corner. And then real quick, I'm just going to make my fill area the same purple as my items. And if you scroll down, set your default value to be 1. So our volume is at max. And so this doesn't move with our keyboard, on navigation we'll set this to none. Also, now if you click Sound Effect Manager and drag in your slider, we'll be all set up. So right now we've got our gem sound effects. So I have a prefab for my gems. If I go here and go to my gem script, we currently have a function where I pick up my gem and it gets destroyed. Before it gets destroyed, we'll have it play a sound effect. To do this, all we have to do is go sound effect manager dot play and pass in gem. And as easy as that, that is how you get sound effects working from anywhere in your game. We know to pass in gem because in Unity on our sound effect library, the name is gem. So you need to make sure your casing and everything is the same as the string. To quickly show you an example of another one, in another element, I'm going to add in player, hit, add a new folder, drag in my sound effects, go to sound effect manager. I'm going to click the lock at the top here and select all my sound effects and drag them into the audio clips list. I open this up, all my sound effects are here. I'm going to unlock this, click on my player, go to my player health script, and in here when I take damage, I'm going to go sound effect manager dot play and pass in player hit. And that's so easy. So for the moment we've all been waiting for, let's press play, and when we pick up a gem, it made a sound! Let's get hit by this enemy. Oh, it didn't make a sound. Let's find out why. Let's go to our sound effect manager. I said play hit instead of player hit. I'm typing faster than I'm thinking. Or I'm thinking faster than I'm typing. Anyway, let's test it again. Now we can pick up an item. Let me get our sound effect. Well, let's get hit by this enemy. Nice! So now if we test our sound effect volume. So max volume. And quiet. Half volume and max volume. Very cool. With this method you can add any types of sound effects that you like. I'm going to add one more for when I bounce on our bounce trap. So you can watch me add this in super fast mode. For my bounce, I'm only adding 2 sound effects. Phase jump 1 and 2. And for our bounce trap, if our trap has no damage, it's a bounce trap. So we can go sound effect manager, play, bounce. Cool, so with that in, I can now have fun on a little bounce trap. Cool, so now you can go ahead and have some fun adding in your own sound effects. By the end of this video, we'll have added a background music manager to our game, as well as a slider where we can increase the volume of our background music, as well as our sound effects. That was in the previous video. Also, when we die, our music will pause, and when we press retry, our music will start again. Cool, let's check it out. So first of all, let's right click and go create empty, call this music manager. On here, we're going to add a component and add an audio source. And then click add component, go new script and call it music manager. If we double click on this to open it up, then in here, just like we did for our sound effect manager, we're going to want a static instance of this. So we're going to go private, static, music manager, instance. With this, we'll be able to call our music manager from any of our other scripts. Next, we'll want a private audio source called audio source, a public audio clip, which I'm going to call background music, and then square brackets serialize field for our private slider. Hover over and click using Unity Engine.ui, and I'll call this our music slider, which we're going to use to set our volume. Cool, next again like we did in our last video, we're going to want to set up our instance. So we want to say if instance equals null, instance equals this, and then don't destroy unload this game object. And above this we'll go audio source equals get component audio source, which will grab the audio source off of this game object. Then we want to say else, if there is an instance, destroy this game object, so we only have one. And we don't need this update, so let's remove this and make a function called public void play background music. I want to be able to reset our songs in case we die and we want to start it again. So I'm going to pass in a boolean called reset song, and I'm also going to pass in a optional audio clip, so we're able to change our background song. If you type equals null, this makes this parameter optional, so we don't have to pass in a audio clip when we call this. So now we want to say if our audio clip does not equal null, we're going to want to set our audio source dot clip to equal our new audio clip. Else if our audio source's clip is not currently null, so we're currently playing a song and we haven't passed in a new one, we're going to say audio source dot play. However, if we do want to reset the song, the way to reset it is by stopping and then starting the song again. So we want to say above this, if reset song audio source dot stop, and then we let it call play. Cool. If for any reason you want a pause button for your music, I don't currently have a pause function in my game, but to do this you'll just call pause background music, which we're writing now, and you just go audio source dot pause. And after using this, you just call play background music again and have reset song set to false. So when I start the game, I want our music to start playing. So I'm going to say if background music, which is the one we're passing in, is not null, as it's going to be our default background music, I'm going to play background music. I don't want it to reset the song because we've only just started. And then I want to pass in background music. So this will play as soon as our game starts, and as soon as this script loads up. That's everything for the music. Now I'm going to set up our slider so we can manage the volume of our music. So we're going to want a public static void set volume, taking in a float parameter called volume. And we're going to want to go instance.audiosource.volume equals volume. So now in start, we want this to happen whenever our volume slider is changed. So same as last time, we'll go music slider.onValueChange.add listener. We'll pass in delegate, curly brackets, set volume, brackets, music slider.value, and then semicolon after the brackets and semicolon at the very end. And quickly, before I forget, we don't want this to be an else if, we want it to just be an if. And that's it. Let's go back to Unity. And in my UI canvas, I actually have one already set up from last video of our volume slider. So I'm just going to copy and paste this and go music volume slider. If you haven't got this, all you have to do is right click on UI, go UI slider, and the settings that we've changed on this down the bottom is set the max value to be 1, set navigation to be none, and at the top I just made the scale 2x2. Now on my scene I'm going to click the move tool, move this down a bit, and real quickly in my UI I'm just going to add some text to both of these. So now we can differentiate between our two sliders, the top one being for sound effects, the bottom one for being our background music. I'm going to click on Music Manager, and in our music slider slot, I'm going to drag in our music volume slider. Now for our background music, I went on to Pixabay, a website that has copyright-free and royalty-free music. I found this one by Lesiakoa called Pixel Perfect. I downloaded this, so now in Unity, I can drag this in to my sound folder, select Music Manager, lock this at the top of the inspector with a little padlock, and drag in my background music into the audio slot. And I'm also going to tick loop in our audio source so our background music keeps looping. So now when I press play, we can now hear our music. I'm going to turn down my background music, which is much better. Now it would be cool if when we die, our music stops and then restarts when we press retry. So let's make use of the functions we added in our music manager. My game over screen is handled in my game controller. So I'm going to go to here. So I'm going to click on my game controller and double click on a script. Then where my game over screen is being set to active, I'm going to call music manager dot pause background music. Now you can see this has a red underline. It's saying it's not static. If we go back to our music manager, we need to set our pause background music to static and our play background music to static. So these can be accessible outside of our manager. Now to get to our audio source in these, if we copy instance dot from above, paste it in front of all of these audio sources, it'll fix our problem. So sorry about that, we all make mistakes. So back into our game controller, our pause background music is now working. And when we reset our game and press retry, and the game starts playing again, we're going to want our music manager to play the background music. And I could have it not reset the song, and I'll show you what that sounds like. If we go back to Unity and press play, once we've let the music run a bit, you can hear we're into it. Music pauses. Now when we press retry, the music continues to where it was left off. This could be a choice in your game if you want it. Let me turn the music off. This could be a choice in your game if you want it to sound like that. But for me, I think I want it to reset the song. So back in the game controller, I'm just going to set our play background music reset song boolean to be true. So when we go back now and press play, again I'm going to turn these down a bit. I'll go take damage on these spikes. So you can hear we're into the middle of the song here. And then when we die, it stops, and when we press retry, it starts again from the slow beginning. But cool, now we've got a background music and sound effects in our game. You don't have to have these volume sliders always at the top, of course. They should be in a settings menu. But for testing purposes, it's quite nice to have them here. Just messing around with default values and stuff. But yeah, very cool. By the end of this video, we'll have created a simple start menu with a simple exit and start button. Exit to quit out the game and start to start the game. Cool, let's take a look. So in our assets, let's go to scenes and right click, go create scene. I'm going to call this start scene. I'm going to double click on this to open it up. I'm going to click on main camera and click on background and set this to be black. I'm going to right click, go UI button. I'm going to call this start button. I'm going to expand our start button, select text and type start. I'm going to make my start button's width 500 and the height 150. Back to our text, I'm going to make this bold and set the font size to be 100. I'm going to select the move tool on our button and drag it up a bit. Copy and paste it, drag this one down, rename the text exit and rename this exit button. Cool, on start button, I'm going to make the highlighted color for start a bright green and the highlighted color for exit a bright red. Next, I'm going to right click, go UI text and call this title text. And then the text, I'm going to type 2D platformer. Just going to make the width super big, like 2000. Go down to the options here, set this font size to be 175, center this in the page and drag it up to the top, make it bold and make it a bright purple to match our game. Cool, now let's get these buttons working. I'm going to click on our canvas, scroll down to the bottom and click add component, scroll down to the bottom, new script, and call this start menu controller. Double click on this to open it up. We can delete these two functions. We're going to want a public void on start click, which is going to handle our start button press. And all we need to do to switch to our game scene is go scene manager, hover over this and go show potential fixes, then select the top one using Unity Engine Scene Management and type .load scene and pass in your scene's name. My scene's name, because I haven't changed it, is sample scene. Now let's write one for our exit button. So on exit click, and because we're actually debugging in the Unity editor, we have to do something a bit weird. Instead of just closing down the executable program as it would be when your game's finished, we go hashtag if Unity in capital letters underscore editor in capital letters and press enter and type Unity editor dot editor application dot is playing equals false and press enter and type #endif. And for if you have built this and have an executable game, we'll type application.quit. Cool, and that's all we need. Easy script. Let's go back to Unity, click on our Start button and scroll down to the bottom. And in OnClick, press the plus, drag in Canvas where it says None Object. Where it says No Function, click on this drop down, go Start Menu Controller and select On Start Click. Then go to your Exit button and do the same thing. So plus on the OnClick, drag in Canvas, Start Menu Controller, on Exit Click. Now let's test it out. If you press play, we can see these change color as we hover over. And if we click Exit, it closes our game. If I press play again, now this time if I press start, our game starts. Very cool. Now just for fun, off screen I've made this little start player that follows my mouse around. Very cute, and has a little idle animation too. Just a little bit of fun for the main menu, make it a little less boring. If you wanted to add this kind of thing to your game, I do have this whole package on my Patreon, as well as all code I've ever used in this whole game series. And coming soon, or it could be up now, I'm going to be selling our whole controller, the whole game I've made. It's about 6 to 8 months of work for you to be able to download and get yourself. Like I said, that's either linked below or I've cut this out and I'm not doing this until next time. But yeah, you'll be able to use this as a template for your own games. But cool, that's it. See you next time. Bye.